just to mention one thing here, kindly join in from landscape mode, because that is where you will be having a more better viewing experience throughout this entire masterclass. Hi Niranjan, we're all excited for this masterclass itself, Shivam, that's for sure. Cool. So I will just give you a quick walkthrough about our platform, how would it look like to all of you, and like how you can also make the best utilization of it. So what I will do is that I will just quickly share my screen, and you guys need to help me out here. Just give me a second. Can you all see GM written in the middle of my screen? If yes, just give me a thumbs up once again. Awesome, awesome. Thank you so much, guys. So this is the screenshot of the platform that you have currently joined in. That is called Drona. This is something that would be looking like for all of you as you have joined in from your phone and your laptops. On the right side, okay, there is a pin, like you can see a blue ribbon that is called the pin section, wherein me and Sandeep, we would be posting all the relevant links there. So click on this drop down menu just to check all the links and use them whenever it is required. Below that is the chat section, wherein all of you lovely folks are already interacting there. But just a heads up, please do not post any sort of unsolicited links. Please do not spam there, because you might be getting auto banned from a system itself. So that's a kind request from my end as well. And please be respectful and maintain the decorum throughout this entire masterclass, just to ensure that you and your fellow learners are having a pleasant experience throughout this entire 3 hours. Now, ladies and gents, again, you will be having a lot of questions throughout this entire masterclass. So what I will suggest you is that kindly post all your questions in the questions tab, which is just below the chat tab. Now, why we are making sure that you are doing this exercise, because as by chance, if you're posting your questions in the chat tab, it will be getting disappeared in the infinite scroll, right? So we don't want to happen like that. So when you're posting your questions in the questions tab, ensure that you are marking, you are upvoting. There is a thumbs up option there. You are just upvoting all the relevant and the most technical questions. So when Sandeep is taking the particular questions in a haphazard manner, he's taking the most important and the relevant questions accordingly. Okay. Now, last but not the least, me and Sandeep, we have prepared some fun polls for all of you guys here. The idea is you people are interacting, and through this particular polls itself, we don't want you to make sure it looks like a Netflix stream here. So we want all of you to be interactive throughout this entire masterclass. So feel free to indulge in this particular polls and click on the desired option and click on the submit button. Because if you're submitting, then only your response would be getting recorded from our end itself. I hope you got a clear understanding of the platform. If yes, again, just give me a thumbs up. Awesome, guys. Again, thank you so much for the wonderful response here. Ashi, unfortunately, you won't be getting the recording for the same, but if you're a Scalar enroll learner, definitely it would be coming on your dashboard itself. With this being said, I have certain few polls to run for all of you guys here, which Sandeep has particularly requested for me, just to understand the general audience for today itself. So just give me a second, guys. Let me just launch the polls. So first poll coming for all of you guys here. What's your domain of work? Now, if you're someone who is working in a non-product based company, now it could be service based or anything, you can just select that. If you're working as a developer in terms of product based companies, you can select that as well. Now, if you're in terms of working in terms of the QA testing or all those particular aspects, you can select that. And last but not the least, you can select the support roles as well. Now, again, this is again to ensure who we are and from where we are joining from. Okay. Most of the people I can see, 48% are saying that they are currently working in developer and product-based companies. That's good to see as well. Don't worry, Prithvi. If you're also in college, it will be a very insightful session as well. I will just quickly launch the second poll as well. It will be coming on your screen right now. What's your work experience in terms of a tech domain? If you're a fresher, you can just select that. If you're someone who is having 0 to 3 years of experience, you can select that. If you're someone who is in the bracket of 3 to 8 years. whatever suits you, just ensure that you are selecting that accordingly, which the idea is just that only. Again, guys, we have around 385 people. We want to ensure that some active participation in seen in terms of these polls here, so that we understand like how you're responding to this particular polls itself. Cool. Somewhere asking regarding the certificate. Sheetal, I will definitely suggest you what you can do is that just go to the last event same page, and you can just get that particular link itself, and you can you'll be able to download the certificate from there itself. With this being said, I can already see Sandeep has joined the session. So good evening, Sandeep. If everything is working fine from your end, without any further ado, over to you.
Hey everyone, hello, good evening folks. Am I audible to all of you? Is my audio video clear?
Absolutely, you are perfectly
okay,
clear.
awesome. Hey everyone, how are you all doing today? First of all, thanks a lot for joining in. Really happy to see so many people interested in learning these concepts. How are you all doing? All good? Awesome? Nice. I see a few names which are already familiar to me. I don't know how many of you are knowing me or having a session with me. Okay, cool. I will share my introduction in a few minutes, but before that, we have someone very important that we want to talk about. So Manideep is here. Manideep, hey Manideep, can you please come up?
Hey, hi.
Hey, so we thought that, okay, we are going to learn about these concepts. Why not bring someone from the industry who's already working as a senior software engineer and get some insights from him that, okay, hey, how important is this thing that we're teaching the students? Like, are we just teaching them something very basic, or we're teaching something very interesting, complex, and important for the industry? So, Manideep, I'll give it over to you. Why don't you quickly give you a short introduction and let us know what you work on so that students have some context. Yeah. Please, over to you.
Yeah. Hi all. So I am Manideep, currently working in a fintech company, Provenir. I started my career from TCS as a fresher, and after that I worked with RCCM, which is a sister company of Deisha, and then I cracked Microsoft along with Slice, which is also a fintech. So basically, if you see past 2 to 3 companies, I have a fintech background. So currently working as a senior software developer with Provenir itself, and the concept which we are discussing, this Java concurrency and multithreading, it's of course it's one of the important factor, especially the developers should know, where all this multithreading along with the main development, either if you are a Java background, you need to have that Spring Boot, or if you are from Python, you need to have some Django. So whatever it is, multithreading is one of the important concepts. Yes.
So, I mean, where do you use multithreading? Like, for example, can you give us any detailed, a little bit of a detailed example in your work? Where do you use multithreading?
One example where which I can recall is that when I am working for this Slice, which is a fintech company, where I work on basically to fetch the loan data. So we have multiple APIs, each pointing to different tables. So when I'm sending a request, basically the request should not keep on waiting for the response to come back, right? Because it's a huge response. It's not a small response. We would be having, in some tables, we would be almost having more than a crore of records. Sometimes it happens. So either you need to have some Kafka for that, or if it is somewhat minimal data, then you need to fetch the data, right? So you use the, after fetching the data, you give it to one thread. And for the next one, you again, for the next request, instead of keep on waiting for the response, use other thread to fetch it. And that data would be automatically redirected to the S3. So the data would go to the AWS S3 directly, instead of being in a local system. So this is one use case which is much helpful when you are when you want to optimally utilize your resources, especially. This is one use case.
So basically, what I'm understanding is that major task is that you want to break down your tasks and you do them parallelly instead of doing them sequentially. So yes. Let's say if I take a simple example, let's say if I'm in a restaurant, then probably one cook is making the starter, another cook is, let's say, making the main course, and so that it's parallelly served to you when you're hungry. You don't want to wait for it to get cooked one by one by
Yeah,
one,
both can go
instead of getting
parallel.
that, right?
You know not.
They both can go
Yes.
parallel. Exactly.
Yes.
Exactly. I mean, what I understand about multi-threading from my experience and all is that it's a very difficult topic to like master. It's a very like even people who are having decent experience in the industry, working with bigger companies, still it's a bigger thing to happen. And also, like debugging in multi-threading is specifically is very difficult thing to do, right? So, can you give me any scenario where you faced any issues or anything like that, or any problem that you might have seen with multi-threading?
Basically one minimal issue, but it's let me point out that, so as I am saying that we need to fetch that data and writing to the S3. So before writing to the S3, what I have did is that I have created a file to fetch the whole data, save it in the local system, and then upload back to the S3 and then delete it from the system. It worked for some requests, but some of other requests, the issue is that few files are not getting deleted. So after some point of time, maybe after 10 days or 15 days, what happens is that the system automatically goes down because there is not enough memory in the system. So then I have used the same thread. Instead of saving it in the local system, the same thread I have utilized it to save it directly to the S3. So where you use this multi-threading along with this AWS SDK so that you can directly point it over there. So now the issue has been resolved. So multi-threading, you need to take care of this. Parallelism is pretty good, but you should not. These minimal changes you need to take care of.
Understood. So now my question is that, okay, you know how to use multi-threading, you are able to fix bugs, you are able to do all these things. You have got offers from Microsoft, Slice, and all these big brands, right? I believe Provenir is a remote company as well, if I'm not wrong.
Yes,
Yes, it's a remote company. So people are dying to work for remote companies. Like every day on my LinkedIn, I see messages, right? So my point is that, going through so many, like upskilling yourself, reaching to a place where you're working with so many good companies and solving such a big problem, how did that happen? Because I saw your profile, I think you started from TCS or somewhere, and from my because I also started from Capgemini, so it's very interesting to know, because I know, I mean, right now I'm in Atlassian. So I understand the journey. So I want to know from you as well that how it worked out for you and what did you do to reach from TCS, because we know those kind of work and project is not present there, right?
Yeah, exactly. So for my upskilling itself, what I have did is that when I'm working in TCS, I feel like, of course, I got a good project and all, but if we keep on being in a service-based company, I felt like we would not grow in the career and also with respect to the salary. Both are important actually. So then I thought we need to have some, I want to work in a product-based company, that too as an SDA and all. So I have inquired what all things which I need to have, which I don't, which skills which I don't have it right now. One is this data structures and algorithms, and also the design part. But if you want to grow high in your career, then you need to learn low-level design, high-level design. So basically, the system design component you need to have. So then, while researching itself, while I have been with the interview bit, which is a coding platform, they have started this scaler. So that's how I got to know. And we follow few in our background, like they take very good decisions, and most of the people in my circle, they have joined Scalar, and I can see this their growth. So on their trust, even I have joined the Scalar, and I know I would be landing in a good company, but I didn't expect that I would land in a very good hedge fund management company called RCCM, and I cracked Microsoft also with the help of my mentor. I need to especially thank him actually, because a day and night, like we had multiple calls and all. So for the upskilling, we need to spend some time. I used to spend from 9 to 12 in the night, so that that's how I did one project and all. That's how with the help of Scalar I could able to join in a good company. Yes.
Great, Manidev. And I totally agree. Like putting the hours, like that burning the midnight oil is the thing, right? No matter what platform it is, it's your hard work that takes you to the.
Yeah, we need to put in some effort. Yes,
exactly. Cool. Thanks a lot, Manidev, for this. Thanks a lot for sharing your journey. Thanks for being an awesome Scalar alumni. Thanks for coming here. So we'll take it forward from here. I hope the students got to learn and inspire from you a lot. Sonajyoti, I mean, if you have anyone else, like I think Manideep and other alums can guide our students a lot. So
Sure.
want to share some information with
Do
you?
the test from my end, and thank you so much, Manideep, for taking your time out and helping us understand your journey in such a prolific manner. So what I will do is that I will just quickly share my screen, and I will show the entire transition that Manideep had. I hope my screen is visible, guys. Cool. So this is the transition that we were talking about. So as you can see, we have got another alumni, similar alumni like Bhaskar Shaw. Similarly, was coming from a service-based company like Accenture, and post-scaler, he's currently working in a product-based company like Walmart itself. Again, coming to Manideep here. Again, you understand his journey itself. Like he was coming from a service-based company, and currently after post-scaler, he's working in RCCM, a software. He's working as a SD there, and he has also already taken so many transition after that, because he's currently working in as a senior software development engineer in Prominent. So with this being said, Manideep, I can see a lot of questions coming from people wherein they want to understand your transition journey. They want to understand like how to get into such brilliant roles. So what I will do is that I will just quickly launch a poll for all of you guys here, because time is very short in here. So ladies and gents, this is a brilliant opportunity wherein if you want to connect with Manideep or similar profiles like Bhaskar in a one-on-one format, this is the way. But the best part is that this is a complete free of cost service that we are providing from Scalar. Okay, and the best part is that there is no mediator in between. So Scalar is not coming into the picture here. You will be connecting with Manideep in a similar sort of format, in a one-on-one basis, in Google Meet or Zoom link. Okay, whatever is the platform it is. So I will request you is that if you are only serious to connect with Manideep, because he's also working professional, so are you. So ensure that you are pressing the yes button and click on submit to ensure that
Deepak, no, we have much more than 2 people. It's just that these are very active and they want to give back to the community. Now, they are working in such big companies. They are very valuable people with their valuable time. But these are 2, and we have more as well, alums who are very actively participating in giving back to the community.
Yes.
Trust me, you will not be able to connect with these kind of people very easily in the industry if you reach out to them directly. So thanks to Manideep and everyone else who is giving out their time for this, right? So
yeah, thanks a lot, basically.
And also, if you want to understand his entire journey, like how did Manideep did, and like their transition journey, and also if you want to get a personalized career roadmap from them itself, because it's very difficult to crack such difficult interviews and get into such top product-based companies like Walmart or so. So feel free to join in this particular poll itself. Thank you so much again for the wonderful response here. So I have also something more to share with you guys here. So with your permission here, Manideep, I will just quickly share the LinkedIn profile as well. So guys, feel free to again indulge in this poll. It's like in this particular link itself. Send out as many as requests as possible. But yes, he will be taking his time out. And last but not the least, let me just share the LinkedIn, the particular WhatsApp profile here. This WhatsApp link here. So wherein Manideep and Bhaskar is waiting for all of you to get all your queries getting concerned here, guys. So feel free to just join in this particular WhatsApp group. With this being said, again, thank you so much, Manideep. Over to you, Sandeep. You can take it forward from here.
Thank you so much.
Thank you. Folks, we are already in session. Whatever we are discussing is part of the lecture. So I don't know how many of you heard what Manideep told about the problem statement, that taking a file from S3 bucket, uploading it to the server, processing it parallelly. Those are all part of the technical discussions. I mean, if you are able to understand that, that's great. If you're not able to understand that, then you have to have a little bit of patience so that we can walk you through the basics, right? So Manideep, what the problem statement that Manideep shared is actually industry related problem statement that he has solved in his company, right? So don't worry about that part. We're just getting started. See, the point is, right, right now, I mean, these things, right, understanding, okay, what is an S3 bucket? How many of you know here, by the way, what is an S3 bucket? Just want to know, how many of you know what is an S3 bucket? Heard the name? Little? Okay, okay. I see a lot of people saying no. Okay. I might have heard about S3, but don't know how to use it, right? Okay. Similarly, if I go and say that, okay, write a code that takes file from database, processes it into multiple in a different way, puts in is an S3 bucket and all that. So the point is that these skills are needed to be required, right? Nowadays, you know how the market is. You know, any one job opening opens, 500 people are applying to it, 1,000 people are applying to it in a single day, right? So the point is, if you want to learn these kind of skill sets, become a all-round developer, not just do DSA crunching, do DSA, work on design, make project development, then you can check out Scalar. Scalar is a full end-to-end full like all-round developer course where we focus on everything. We just don't do DSA crunching. We just don't do like doing a lot of DSA and DSA. We spend a good amount of time on DSA, then we go on low-level design, we go on high-level design. We go through a specific project module. I'll talk about this later if we get some time. So we'll talk about that later. But if you're interested to become an all-round developer in this industry, it is important. Those times are gone that you can just crunch a DSA and get a job, right? You have to prove yourself as a developer, get a job and prove inside the company as well. Either you know all these fine companies, everybody's laying off. If you don't perform, the place is very bad for you. So the thing is that if you want to know this, just let me know. Like, let us know if you're more interested into Scalar. So I'll ask Sonajyoti if we can just launch a callback poll. Just answer this poll. Simple yes will take you to our counselors. Our alumni will connect you with them. We'll talk to you. We'll understand you where you're standing. We'll discuss with you what Scalar offers. I mean, it's a genuine thing, being very honest. It's a genuine, we'll talk about it, is that yeah, definitely, Roman. We have multiple developers who have joined with experience. People who are working at good companies have also joined and got a promotion or would have switched to their dream companies. Nowadays, I see a lot of people are wanting to join remote companies. For example, if I see Manideep is working in Provni, I am working in Atlassian. These are all remote companies. You don't know every day how many messages I get on LinkedIn, people wanting to join Atlassian just because it is remote. So those things will happen only when you are very good. Those opportunities are less. The COVID era is gone. Offices are calling you back. So if you want to go into those companies which are, let's say, hiring you for remote work, who are hiring you for hybrid work, you need to be the very best that you can be. You have to beat the talent around, right? So for that, Scale is the thing. So just letting you know. Yeah, see, I am getting a lot of messages that I also want remote. I have family issues. I have a lot of things. I understand, man. It's important, right? So anyway, let's begin. Let's get started. Just quickly let me know if you can see my screen. If the screen is visible to all of you. Is my screen visible to all of you? Okay, awesome. So this is what we are going to talk about today. We will go through the concepts of multithreading. We'll start from the very basics and we'll go to the pretty much advanced level. So we'll talk about what are threads. We'll talk about difference between concurrency and parallelism. We'll talk about how to create threads. We will talk about steps for writing a multi-threaded code. So see, my agenda for today's session is that you go back with the fundamental knowledge, that you have enough basic fundamental knowledge which you can apply into any code, into any project. Okay? After that, we'll talk about how threads can return data if they can. I mean, if threads can return data or not. And we'll also talk about something known as executor service, and we'll look into that. Okay? Just one thing, FYI, we will be doing all the implementations in Java. We will be basically talking about all the implementations in Java because, as you can see, the topic itself says Java concurrency and multithreading, right? So that's the thing. Let's get started. Before we start, I'll take last 30 seconds to quickly introduce myself because a lot of new names are here as well. A lot of known names are here as well. So my name is Sandeep, as you can all see, right? I am a 2019 graduate. I'm currently working in a company called Atlassian. How many of you know about Atlassian? Anybody knows Atlassian? Can you name some products of Atlassian? Jira, Atlas, Confluence, Bitbucket, Trello, Confluence. Nice, good. So all of you know, right? That's great. So I'm working in Atlassian right now as a full stack engineer. Prior to this, I was working in a company called Visa. Had a very short tenure as a senior software engineer. Prior to that, I was working in Azure.com as a backend engineer. And I started my career from Capgemini as a software engineer way back in 2019. I am from Techno India College. I don't know how many of you know this. It's a tier N to the power N college. I don't know what tier you will call it. But yeah, this is my college. I've been passed out from Kolkata Techno India. And that's all about me. Cool? Works? Chalo. Let's get started. Okay? Let's begin. So, Kanhaiya also worked in Ajio. Nice. That's great to know. Hello, Bhaiya from Jadavpur. Nice. That's great. Cool. My neighbor college, I watch it every day. Oh, nice. A lot of people here. Okay. So, let's start. Few questions quickly sharing. I don't know why I get these questions every time, even though it is clarified. Just letting you all know. You will not be getting the recordings if you are not a Scalar student. If you are a full-time Scalar student, you'll get the recording. So, no and yes. Yes, only for Scalar students. Will you get the notes? Yes, you will get the notes. Will you get a certificate? Yes, you will get a certificate. Cool. All these things are done. I am also, I don't know why I get this question a lot. I am using an iPad with Notability application. So this is the application that I'm using. That's it. Keeping all these things aside, let's go back and start into the topic. Okay. Cool. Let's, Swarnajyoti, if you can please share my LinkedIn ID, it will be great. A lot of people are messaging for the same. Just tag it here. Let's get started, folks. Okay. Chalo. So what is multi-threading? How many of you know what is multi-threading? Just be very honest. How many of you know what is multi-threading? Read the pre-read. Okay. ठीक है. Cool. So what do we do? Let's talk about the work that software engineers do, right? It looks very fancy from outside, but let's actually understand what software engineers do, right? Okay. So software engineers, what do? They write some code. Okay. What happens to this code? What happens to this code? After writing the code, what happens? Do you know? Compiled. Okay. ठीक है. Compiled and build. After that, what happens? Deploy. Okay. So it depends. If it is a web application, you will deploy it on a server. If it is an app, like an app, let's say an iOS app or a Android app or a Windows app, you will create an executable file, right? You'll create an executable file, a file that can be executed. Then this file will be like either you will reach to the server or you will download it. Let's say download it. Then you will run it on your machine. Run on machine. So it will either run on your own machine if it is an application, or it will run on the server if it is a web app, right? On your own machine or server, right? Simple. Okay. And what it is running on finally, what is that machine where it is running? If it is your installed application or it is a web app like scalar.com, youtube.com, they are all running on processor. Exactly. They are all running on processor. At the end of the day, they are all running on a CPU, and CPU consists of processor. CPU consists of other things as well, but majorly processor, right? Okay. Now, whatever we execute on a CPU, on a processor, what do we call it? Whatever is executable on a CPU, what is it called? Can anybody tell me? What do you call that thing that executes? Is it a process? Are you sure? First comes program. Before process comes program. Okay? Before process comes program. So a little bit of operating system basics we'll discuss about here. And I want to know how many of you will say, I wait for 10 minutes and then I want to see how many of you say, this was in college. I wish I would have studied that in college. I'll come back to that. Okay? So process program is something that can be executed to cause a particular action. Right? Something that can be executed to cause a particular action, right? To cause a particular action. Now, what is process? What is process? Process is nothing but a program in execution. Exactly, Nishit. A program in execution. When a program can be executed, correct? I can execute a program, but a program in execution is called a process. Okay? A program in execution is called a process. As simple as that. Okay. Where does a process, like where does it execute? It is executing. So where does it execute? Where does it execute? CPU. Exactly. Executes on CPU. On CPU. If I say where exactly, CPU means processor. Correct. And where do you store the data for this process? Where do I store the data for this processor? In the RAM. Exactly. So we have cache memory as well. We have buffers as well, but registers and buffers. But majorly, RAM is the main holding of the data. Like main is the one who loads the process and everything, right? Okay. Now, the point is, let's see what happens, right? Let's see what happens now. all of these, let's say you are right now, how many of you are on, like most of you are using a browser, right? You are on a Chrome browser. So let's say you are on a Chrome browser, right? Okay. Now inside the Chrome browser, their Brave browser is internally Chrome itself. Shivam, by the way, it uses Chromium itself, right? Let's say inside the Chrome browser, you might be opening multiple tabs. I hope you are not opened multiple tabs, but let's take an example that you might have scalar.com, right? You might have, let's say, youtube.com. You might have, let's say, whatever, let's say something else, interviewbit.com, right? I hope nothing else, Nick, you don't have anything open, right? Okay, LinkedIn as well. Okay, so looks like a lot of people are like searching for jobs and scrolling through a lot of profiles. But anyway, now the point is each of this tab is running a different process. Now internally these tabs will be running multiple things as well, but let's to take a high level idea. This Chrome itself might be running as a process. Each tab will be running as a process as well. Let's say tab 1, tab 2, tab 3. Each of them will be running as a process as well. So these are the different processes that run. Now the question comes that, okay, Sandeep, that there is one CPU, there is one processor, right? Okay, there is one processor, but how am I able to run so many things parallelly? Like in this tab itself, if you see this particular scalar window, there is a process running for giving you my video visuals, right? You're able to see my video. There is one going on for my audio. There is one going on for my screen shared. There is one going on for the chats. How is all these things happening parallelly? How is all these things available parallelly? This is because of multi-threading, right? Now let's understand where this multi-threading comes from. How are we able to do multi-threading? So multi-threading, multi means multiple things, more than once. Threads, we'll talk about what is threads, right? Let's talk about that. Okay. Before we go into it, let's understand how like a CPU executes it. Okay. So let's understand how it executes it. Okay. So processor in a computer actually is not a single unit. It's a combination of multiple things, multiple units. Do you know what is that combination? What do we call those small things inside a processor? Anybody knows? Let's say a processor consists of multiple small things. What do we call it? We call it cores. We call it cores. Okay, let's talk like in a bit more. If you want to emphasize, it's called cores, right? Cores. Cores is equal to, let's say, the brain of the CPU, brain of the processor. Think of it as the brain of the processor. Okay. Now, you might have heard all these terms, right? Octa-core, quad-core, dual-core, Snapdragon octa-core processors, right? You might have heard performance cores or efficiency cores. iPhone and everything launches, right? So that's the thing. Now, let's see. Before we go into cores are basically physical parts inside the CPU. Okay. If you take a processor in your hand, you might not be able to see it, but in the architecture of the CPU, cores are physical, like physical things inside the processor. It's not something which is on software level, it's a hardware level thing. You can see the cores. If you go to any like person who is like, who knows about processors and all, they'll be able to show you how one processor contains multiple cores. Okay? These are hardware things. Now, how do we use these hardwares? What do we use these cores for? Okay. So let's say if I have to pay someone, let's say I made someone work, I have to pay someone. How will you pay them? How will you pay them? You'll pay them with money. Some money you'll pay them, right? Now, whatever payment option is you have, you can give cash, you can give Paytm, you can give UPI, you can do phone pay, whatever it is, right? You can, but you have to pay them money, right? Now tell me, what is the smallest possible unit of payment? If I say, okay, what is the smallest possible unit of payment? What will it be? 1 rupee? 1 rupee? Right? Correct? There is no denomination called paisa, right? There is no paisa denomination. There is a 1 rupee denomination, lowest. So I'll say that, okay, you will do 1 rupee ka payment. That is the smallest possible unit for payment. As simple as that. Similarly, when CPU does a task, if it wants to compute, okay, what is the smallest possible unit of execution of a task in CPU? That is actually 1 thread. one thread, not a core, a thread. Okay, so think thread is nothing but 1 unit of CPU execution. Okay, so if I say what is the smallest unit of payment, as a concept payment, you are paying 1 rupee, smallest possible unit. If you want to pay more, you pay multiple of 1 rupee, right? It's always a multiple of 1 rupee. It's a 10 times multiple of 1 rupee, 20 times multiple of 1 rupee, 100 times multiple of 1 rupee, but the multiple of smallest unit. Similarly, whenever we execute process in the CPU, it is a multiple of thread. Thread is the smallest possible task execution that you can do. Okay, thread is the smallest possible unit of task that you can execute on any processor. Okay, now where does it execute? Where does the thread is actually executed? Thread is a task concept. It's a software concept. It's not a hardware. There's no thread, like there is no dhaga, right? There's nothing running on the CPU called a thread. It's not like that. Think of it like, okay, I have to do a big task. I'll break it down into smaller tasks. So 100 tasks I'll create, and I can give each task to one thread. Okay, so thread is the smallest execution of task. It's a breakup of task. Okay, where do you execute this breakup of task? Where do you execute this thread? You execute this thread on cores. The cores that we just talked about, we execute the threads here. So a core executes threads. Cool. Now tell me, how many of you had this in your engineering college days, in your BTech days, and how many of you have not studied well? Just give me a thumbs up if you have not studied well and it was there. Like, how many of you feel that I should have studied well? Yeah, so many of you. Do you feel bad? Do you feel guilty that I would study this now and all? Yeah, don't feel. The reason is, I also used to feel the same, but the major reason is, at times it's not about you. At times it's also about the teacher. It's also about the way they teach. These kind of concepts are very complex to study. So we have been associated that if you don't study, it's your fault. It's not always that, right? So yeah, exactly, Shantanu. So it always feels like you have wasted time. You did something else. You could have studied. You could have done that. It's how we are brought up. We have been taught that if you don't study, it's your fault. If you don't score good, it's your fault. Not always. At times, the professors and the management are so bad that even if there is some spark in you, it kills off. So it's okay. What can you do? So that's why I wanted to say this. Don't feel guilty. It's good that you are here. You're putting efforts now. So if you put effort now, and still if you don't get a good instructor, you don't get a good curriculum, you don't get a good place to study, then it's also not getting effort. But anyway, let's come back. Okay. So thread is the smallest execution of task. Thread executes on core. A thread can only execute with a core. So coming back to this point, every thread needs core to execute. Now, tell me, any process, what did I tell you? Thread is the smallest unit of task execution. Any process, is it possible to execute any process without a single thread? If somebody makes a statement that I will execute a process without using a thread, is that possible? No, not possible. So every process needs to have at least one thread. Every process needs to have at least one thread. At least one thread is required. Okay. So let's take an example. How many of you have written Java code here? Even basic hello world. How many of you have written Java code here? Just basic hello world. Nothing more than that. Just a basic hello world, at least. You've written basic Java code? Okay. So you might be thinking, right, that Java code that is running is also a process because it's executing on the CPU. That means it is executing somewhere. So what happens there? Let's see. So let's say if I write a code, simple code. Let's say I write a class called main. Class main. Public static void main. I hope all of you know this. String args. Then print out hello world. Right? Okay. Now this is the code. If I'm running this core, if this code is running in my CPU, Tell me, there has to be one thread involved. There has to be thread involved because it's a process running in my CPU is executing. So every process needs a CPU. So do you know which, what is the thread? Any idea? Main thread, exactly. So the thread that executes the code is called main thread. That's great, Jatinder. Do share some insights if you feel in the lecture. Main thread, right? So main thread is the thread which executes the code. So no matter how many classes you have, no matter how many methods you have, everything in Java executes on a single thread by default. That is called the main thread. Okay. So the point is that no matter how many classes, no matter how many, so let's say if I create a class main, inside this I have a method called public static void main, right? Inside I have a method called, let's say, do. Let's say I have another class, let's say I have another thing called print, right? Even if I have multiple methods, even if I have multiple things, it does not matter. Okay, it does not matter. The reason it does not matter is because everything that you write in Java by default runs by main thread. So by default, so I'll write it down, no matter how many classes / methods we have, all the code runs in a single thread called main thread. That means Java by default is running as a single threaded application. Cool. So that's the main thread, right? That means I need to make it better. And we'll see how we can make it better. Okay. Okay. Let's see. Let's move forward. We'll see how to make it better. Okay. We'll see. Okay. Now let's understand some important terms in OS, right? Before we deep dive into the coding part with Java, let's understand a little bit about the process and how like OS thinks, right? It's important to have that fundamental knowledge. So let's talk about two terms. One is called concurrency and one is called parallelism. Okay. What are these two things? Right? What are these two things? What is concurrency? What is parallelism? Okay, let's go back sometime. Let's go 10 years, 20 years back. We have few people who have that experience. Do you remember there used to be a computer called Pentium? Pentium 1, Pentium 2, Pentium 3, Pentium 4. How many of you used Pentium computers? Yep. Windows 98, Windows 2000. I think XP also was still Pentium only. Yeah, XP was also in Pentium itself. Yes. Now, from Pentium we moved to some new processors, dual core and core to duo kind of processors. Remember? Yes. Dual core, core to duo, and that was, I think, Windows 7 and all came in, right? Yeah. Now we have in the industry i3, i5, i7. We have AMD's Ryzen, we have M1, M2 from Apple. We have all these processors in the market, right? Okay. Now, what happens? In Pentium, we used to have only one core, single core processors. Then we got dual core processors, 2 cores. Now we have like plethora of cores. We have like 4, 8, 16, 32. I mean, there is something called as a Threadripper. I think it has 64 cores. AMD Ryzen Threadripper, if I'm not wrong, 64 cores or 32 cores. So now we have like plethora of cores that we have, right? Okay. Now the point is, we understood that, okay, multi-threading means multiple threads running together. That means doing multiple tasks together. Great. But if there was only one core, how could multiple threads run together? So if I go back to this time, that means people were not able to do things parallelly. Was it true? Those who have used old computers, Windows XP and all, were you doing only one task at a time? Were you doing only one task at a time? No, you might be running Windows Media Player plus Internet Explorer, right? You might be running MS Excel with Windows Media Player. So multiple things were running. So how was that working with a single core? How was that working with single core? So that was actually working because there was something called as concurrency. There's something called as concurrency. Now, what is concurrency? Let's understand. Okay. See, it is for sure that one thread needs one core at a time. One thread, one core at a time. Simple. But let's see. Let's imagine this is my thread. Okay. Now I have, let's say, three processes. Let's say I am running Internet Explorer. I'm running, let's say, Windows Media Player. And I'm running, let's say, anybody can tell me what is this sign? Can somebody tell me what sign is this? Let's see how many of you remember. Correct. VLC. So let's say we are running these three things parallelly. Very good. VLC thinks as that we're running these three things parallelly. Now, if there is a single core, it will not do parallel work. That is obvious. But what it actually does is, see, let's say I executed A little bit. Okay. The core said that, okay, the thread which is executing A, give me that thread. Give me the thread A. Thread A executed a little. That means it made some progress, little bit of progress. Then it went ahead and said that, okay, now I will do a switch. Now B will come. Okay. B will say, okay, let me execute a little bit more. Okay. B executed a little bit more. Then C executed a little bit more. Now, let's take a simple scenario. Let's say A progressed 10%. Then B came in. Then B progressed 10%. Then C came in. Then C progressed 10%. Now imagine for the user who looked at them at 0, 0, 0. Now for us humans, the perception is like very low. I mean, the perception is, I will say, very high. The perception time is very high. That means for us, we will not be able to understand what happened in 10 milliseconds or 100 milliseconds. We will not be able to identify that. We will be able to identify 1 second, half a second and all, but we will not be able to identify what happened in 10 milliseconds or 50 milliseconds. Our brain does not work that fast. But this switch that happened here, that happened, let's say, all three of them happened in less than, let's say, 500 milliseconds, right? So for us, it looked like, oh, from 0, all three of them went to 10%. That means all three of them are running parallelly. But are they running parallelly? Are they actually running parallelly? They're not. So what happens? They do a lot of switching, and that switching is called context switching. Okay. So, but for us humans, it looked like, oh, this is running parallelly. It is working so well. It is running parallelly, but no, it was actually context switching. Okay. Now this keeps on happening in some random order. It can also happen. We don't know what is the order. Order is decided by the operating system and CPU, but randomly. But the point is, it is not acting parallelly. It is acting like sequentially with context switches, right? Sequentially with context switches. Okay? This is what is called concurrency. Concurrency creates an illusion of parallel work. There is no parallelism. There is no parallel work happening. It's illusion of parallel work. Illusion of parallel work. It looks like it is parallel, but it is actually not. I hope that makes sense. So if you have to make it more understanding, right? Let's keep an example. Let's say that you went to a restaurant. I don't know how many of you know this. A restaurant called Barbecue Nation. Yep. Barbecue Nation. You guys know Barbecue Nation? Yeah. Okay. So the Barbecue Nation is basically you go and get a lot of dishes. Like they give you n number of dishes to eat from, right? I don't even know the count, like 20, 30, 40 dishes. You can eat unlimited. It's a barbecue, right? It's a buffet. So you can eat. Now, the point is, let's imagine that you went alone. Let's say you don't have any friends. You went alone. Okay. Most of the software engineers don't, so it's relatable. So let's say you don't have any friends. You went alone to eat in Barbecue Nation, and you were given, let's say, 7, 8, 10 dishes. Now on the 7 or 10 dishes, let's say the waiter came in and said that, okay, you have not eaten anything. Like it's completely fresh. Everything is fresh. Now what you did, okay, you ate little bit of this, you ate little bit of this, you ate little bit of this, you ate little bit of this. Now you did not complete anything fully, but you ate little of 4-5 dishes. The next time when the waiter will come back, the waiter will see, oh, he has finished this, all of them around 20-25%, he has finished these plates. The waiter might feel that you are parallelly eating all the things. How will you be able to eat all the things at the same time? I mean, obviously the waiter time is much higher than what happens inside the CPU, but I'm giving you an example that if the waiter comes back in less than a second, it might look like you ate everything at one go. You ate everything parallelly at one go. That is what happens, that we are the waiter and CPU is crunching the tasks. CPU is the one which is crunching the task. So because for us, it is not possible to perceive that time limit. It feels like it is parallel, it is illusion, but it is actually not parallel. It is constantly switching the tasks and doing some progress here, doing some progress there, doing some progress here, doing some progress there. That is how it works. Okay? Now, the next point is parallelism. Now the next point is parallelism. What is parallelism? What is parallelism? That means we have more than one course. Only possible when you have more than one course. So minimum number of cores that is required for parallelism is exactly minimum number of cores should be 2, because in one core I'll not be able to do any parallel work, right? So parallelism means it's truly parallel. It's truly parallel. Like you have, let's say, 2 threads. Let's say you have 2 threads. So a task A is running at the same time another task B is running. So they are making progress together. Okay, there's no switch can also happen, but even if I go at a very minute 10 milliseconds, 20 milliseconds level, it is actually executing parallelly. Okay, cool. So this is basically your parallelism. So parallelism means running truly parallelly. Running truly parallel. So parallelism does not seem or perceive or illusion of parallelism. It's truly parallel. Parallelism is truly parallel. Now, in the real world, in the CPUs that we have, both go hand in hand. Both go hand in hand. So what happens? But just to complete the example with Barbecue Nation, if you go to Barbecue Nation with a friend now, both of you can eat dishes parallel to each other. So let's say you are eating this and your friend is eating this. So you can consume dishes together at the same time. So it will make things much faster. It will make the consumption much faster. Okay. Now what happens is that coming back to the point is that in the real world, it works together. It works together. It works concurrency plus parallelism go hand in hand. Cores execute concurrent threads plus parallel execution happens. So in the real world, concurrency and parallelism go hand in hand. Concurrency at a particular core and parallelism at different cores. Cool. Now, coming back to the point is that okay, so 4 threads running 2 cores. Threads is not dependent on the course. You can make as many threads as you can, but the execution of thread is dependent on the course. Understand that thread is your construct. You are creating threads, so you can create 100 threads, but the execution of the threads is responsibility in the course. You cannot execute parallelly 100 threads, truly parallel 100 threads. Okay. Now if you see a general number, it's basically number of cores into 2. There's a concept called hyperthreading. So if you read about it, there's a concept called hyperthreading that says that whatever number of cores you have into 2 is the number of threads that you can execute parallelly. Okay, that means if I have 4 cores, I can execute 8 threads parallelly. Okay, this is how it works. You can create 800 threads. That doesn't matter. Execution matters. Okay, execution matters. Cool. So let me ask you one question. It is normal. Every CPU has hyperthreading nowadays, Shivam. It's not like the case. Every CPU nowadays has hyperthreading. Even the lowest i3 has hyperthreading. Okay, so that's the thing. Can we have threads without process in cores? Obviously not. I mean, what is the use of thread if there is no process? You are executing something, it's a process, right? Now, let's move forward. If a CPU, now my question is simple. If a CPU can do parallelism, can it also do concurrency? Tell me, what do you think? The answer to that would be yes. Okay. And if a CPU can only do concurrency, if a CPU can only do concurrency, can it also do parallelism? Answer would be no. Exactly. That means if it is only able to do concurrency, that means it's a single core CPU, not be able to do that. Right? Okay. So now I'm believing that you have the fundamentals clear. Can I get a yes from everyone if you are all clear till now? Concurrency, parallelism, everything clear, core threads, all these things are clear. If everything is clear, now we need to jump into writing the multi-threaded code. That's why we are here, right? Once the fundamentals set, let's move forward and see how we can actually write multi-threaded code. Okay, all good, awesome. Let's move forward. So, how do you write multi-threaded code? Right? How do you write multi-threaded code? Let's see. So, how to write multi-threaded code? We will go step by step. Okay, we'll go step by step. The very first rule that you have while you're thinking of writing a multi-threaded code, the statement itself is wrong. Don't think of multi-threading. Don't think in terms of how many threads you want. Okay? Don't think in terms of threads. Forget about threads. That I want 4 threads, I want 6 threads, I want 10 threads. Forget about that. Forget completely about that. Think in terms of what task you want to achieve or you want to run parallelly. Okay? Think in terms of what tasks you want to run parallelly. Think in terms of that. Okay? Forget about threads and everything. Just forget about that. We are a problem solver. Software engineers are problem solvers. We will not go steps on, okay, I want this, I want that. Think about what you want to do. That's the major important point. Okay. So let's start this. Let's try to build this. Let's start with a very basic program because I also want to get you hands on the syntax. So let's not take a tricky problem. Let's start a very basic problem, but let's understand the core fundamental at how we can do this in multi-threading. Okay. So a simple question is, if I print a hello world in Java right now, which thread will print it? If I print a hello world in Java right now, which thread will print it? Main thread will print it. I want to print hello world from a separate thread. Print 2 hello worlds. Print 2 hello worlds. One from the main thread, one from a separate thread that we will create. Okay, that's the task. So the task is create a multi-threaded program. Create a multi-threaded program which prints hello world from a separate thread as well as main thread. Okay. Now, first of all, let's do it step by step. Okay, let's do it step by step. Step number 1, identify the task. What is the task that we have for this assignment? Can somebody tell me what is the task that we have for this assignment? Print hello world, correct? Print hello worlds. Okay. Print hello world. Cool. This is the task that we have. Let's go to step number 2. Step number 2 is create a class for that task that you have identified. Create a class for that task. Okay. So create a class for that task. Okay, what is the class that we will create? Let's say the class name should actually tell us that what it does. Okay, the class name should be able to tell us what it does. So we'll say that, okay, class hello world printer. Please make a note that the name of the class should be like displaying what it does. So the name should be a noun doing a verb basically. Okay, class name should be a noun doing a verb, basically doing an action, just to be clear. Okay, cool. Now we've created the class. Now what's the next step? Step number three is that you make that class implement runnable interface. Implement runnable interface in that class. Okay, why runnable interface? A lot of you will have that question that Sandeep, I can also extend thread class. So there are two ways to do it. One is extending thread class, another is implementing the runnable interface. Why runnable interface? Any guesses? Anybody wants to have a guess? Any idea? Multiple inheritance. What multiple inheritance? Exactly. So the point is, if in case I extend thread class, does Java support multiple inheritance, everyone? Does Java support multiple inheritance? No. So if the moment I extend a class, will I be able to extend anything else? No. But if I implement an interface, will I still be able to extend a class or implement more interfaces? Yes. So it is clear why we are not extending thread class and implementing runnable interface. Correct, Madhusudan, you are right. Extending the thread will limit the functionality. Everybody clear? Cool. Okay. Let's move forward. So what you will do, basically you will write class hello world printer implements runnable interface. Okay, all good. Now what do you do? This runnable interface has a method called run. Okay, runnable interface has a method called run. So you will need to implement the run method. Okay, need to implement run method, and this method will execute the task. So this method will contain the task that you actually want to execute. Okay. So step 4 is simple, implement the run method. Step 4 is simple, implement the run method. What do we want to do? What is our task? What do you want to do, everyone? What is our task? Print hello world. Simple. So the code will look something like this. Class hello world printer implements runnable. Then we will have a method called public void run. Just do one thing, put a focus on this void, keep this in your mind. I'll come back to it. Okay, I'll come back to it in some time, but just keep a focus on this, right? Print out s out hello world. So till now, step number 1 to 4 was basically for us to do the task definition. Okay, task definition is being done from step number 1 to 4. Okay, task definition being done from step 1 to 4. Now the thread creation comes in. Okay, now comes the thread creation part. So step number 5 is basically the final thread creation part. Thread creation. So what do we do in thread creation? Simple. In thread creation, number 1 is create the object of the task class. Create the object of the task class. Step number 2, create a thread using the object. And number 3, call the start method on this thread.start. Okay, so let's do one thing. Let's jump onto the code and see this in action. Okay, let's jump onto the code and see this in action. Okay. Let me quickly share my screen. Let me know once it is visible to all of you. What I'll do, I'll create a new project in IntelliJ. Let's create a new project. Let's call this project multithreading Masterclass. The date is 21st September. Nice. Let me know if my screen is visible to all of you. Just give me 1 minute. Loading it up. Visible now? Yes? Okay, awesome. Is the code readable to all of you? Clearly readable? You can see it's a hello world code, simple hello world code. You can see hello world is being printed, right? Okay, awesome. So what I'll do, everyone, is that I'll just make a change, okay? Just make a change, okay? Make a change here is that hello world I want to print from the thread, okay? I'll now print from thread. Let's see the thread name. What is the name of the thread? So how to print the thread? Thread dot current thread dot get name, okay? Thread dot current thread dot get name. This will give me the name of the thread. And what is the name of the thread, everyone? What is the name of the thread? Main. So let's run the code and see. Do you see the thread name here? Name of the thread you can see here. Main thread. Okay, awesome. What is our task? To print hello world from a separate thread as well. 2 threads. Okay. Step number 1, create the class. Give the name hello world printer. Class created. Step number 2, implement runnable interface. Implemented. Step number 3, implement the run method. Public void run. Step number 4, put the task that you want to do. So I want to print hello world, but I will also print from which thread I am printing this. So thread, and I'll put thread dot print thread dot get name. So give me the name of the thread which is printing this line. Clear? Any doubts in this code, everyone? Any doubts? Can you all give me a thumbs up if it is clear to all of you? Can you all thumbs up if this code is clear to all of you? This part, this much part. I need a quick thumbs up from all of you. I don't see enough thumbs up, everyone. Okay, thank you, Annie. Cool. Okay, awesome. This is clear. Nice. Okay. Now let's come back to the main. Now what we want to do? We want to go ahead and create an object of the task class. So let's create hello world printer. Let's call it HWP equals to new hello world printer. Now what I will do is that I'll create a thread. So how do I create a thread? Simple. Thread T1 equals to new thread. And what do you want to execute in this thread? This task HWP. And simply just do T1 dot start. That's it. Done. So just going ahead and discussing what I said right now. Step number 1, create the class. Okay. Step number 2, implement runnable interface. Step number 3, implement the run method. Step number 4, add the tasks of the run method. As simple as that, right? This is done. Then go to the main or wherever you want to execute this. Create the object of the task class. This is the task class. Create a thread object and then start the thread. So if I run the code now, do you see hello world from thread main and hello world from thread 0. Is this thing clear? Yep. Clear? So you can see two things are printed out. Hello world from the main, hello world from the thread 0. As simple as that. Basic, right? Nothing major, no fancy things, not difficult, not complex, simple. Okay. So sort of every thread name starts from thread 0. So the threads that start in there are starting from thread 0. Okay. Now this is the case, right? This is the case. You can write it in one file as well, but not recommended. Okay. Now moving forward, right? Moving forward. All of you would be thinking, Sandeep, you wrote the run method here, but you actually called the start here. Why? What is the difference between this run and this start? Why did you not call the run method? Let's see what happens when I call the run method. Let's see what happens if I call the run method. Let's see. Moment I see the run method, see this. You see thread with main and thread with thread 0. Okay, let's call with the run method and run this. You see both are main. Do you see both are main? Why main? Why not a new thread? Why? What is the reason? I created a thread object. Why it is not a new thread? Why it is main? Why is that? And if I do a start, then it creates thread 0. What is this difference? Let's see. Let's jump back to the iPad. Can you guys see the iPad? Everyone? Are you able to see the screen? Yep. Okay. So basically there are two methods famous in thread, which is run and start. So what run method is, right? So let's talk about the run and start. See, the run method basically contains the task that you want to execute, right? Contains the actual task that we want to execute, correct? But when you call the run method, right, it starts on the same thread itself. Starts, or else should say better term, because start will make you confusing, executes on the same thread. I'll show you the flow, don't worry, on the same thread. But when you call the start method, what internally happens is that it first generates a new thread. It spawns a new thread. Okay? Spawns a new thread. Basically creates a thread on your machine and then calls the run method on that thread. New thread that you created. So let's see what happens internally. Let's go more deeper into the picture. So let's say if this is my code, right? Let me try to see if I can bring the screenshot of this code into my chat, into my board, because I hope Apple works as it promises. Awesome, it worked, great. So is this readable to all of you? Are you able to read this? Readable? I think let's make it better. Let's delete this. I'll change the code a little bit here. I'll not keep it that the width is more than the height. Now let's paste it here. Paste it. Awesome. This is better. So if I go through this code, right? See, let's see if I go through this code, what happens? Okay. So when I go through this code, this line, let's take a different color so it's better in readability. This line starts executing from which thread? Which thread is it executing from? It's executing from main, right? Okay. Again, same, this print line is executing from main. So when this line will print, this will print hello world thread. So it will print hello world from the main thread, because the current thread is right now main thread, right? Okay. Now, next, object creation. Object creation happened at what thread? Tell me. Object creation happened at what thread? Main thread itself, yes. Thread object created again on main thread. But the moment, so everything till now was executing on the main thread till now. The moment it hits start, what happens? Your main threads keeps on continuing, but it spawns a new thread called thread 0. On this thread 0, it will call the run method. Okay, this will create a new thread called thread 0 and it will call the run method on this thread. That is how it works. Okay, let me jump back into the code and see what happens. Okay, let me jump back into the code and see what happens. So let's do one thing. I want to show, let's see the trick, that how many of you can answer this. Can you all see the screen? Can you see the screen? Yes, okay. So what I'll do, I'll print out a number 0 here. I'll print out a number, or let's say number 1 here. I'll print out a number 3 here. And inside this run method, I'll print out a number 2. Okay. So if you see, Number 1 is in the beginning of the code. Number 3 is after the thread has been created. And number 2 is inside this run method. Okay. Now my question is, can you tell me what will be the output? Will the output be 1, 2, 3? Will the output be 1, 3, 2? Will the output be 3, 2, 1? Or will the output be 2, 1, 3? What will be the output? You have 4 options. Let's see. Let's run the code and see what happens. Let's run the code and see what happens. So we got 1, 3, 2. Okay, let's run it again. 1, 3, 2. Again, 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 1, 3, 2. Why? Why is it not coming random? Why not random? Why not random? Let's see. Why not random? Let's understand that. Okay, let's understand that. Let's take the screenshot of this code and put it on the iPad and let's discuss. Can you guys see the iPad? Yep. Okay. Okay. Let's see. So what happens? Simple. Let's see. By the way, one question I want to know. This line number 3, this 3 is being printed by which thread? Thread 0 or main? Because I have created the thread 0 here itself. Thread 0 is created from here. Will this 3 print via thread 0 or via main? Correct. Very good. It's from main because thread 0 will only take care of the run method, nothing else. Okay. See, basically what happens, till here you have main thread going on, right? So this is quite obvious that 1 will come in the very beginning. It's obvious, right? There's nothing else going to happen, right? It is always going to be measured, right? Okay. Now, the moment I call thread.start, see the main thread's task here is, the task of the main thread here is when you call thread.start, the task of the main thread is to spawn up a new thread. So it will create a new thread called thread 0. Now spawning up a new thread is generally an expensive process. It takes time because you're allocating resources to it. You're telling the OS that I'm spawning a new thread to get this task done. So internally it takes some time. Like the very milliseconds, microseconds, but it happens at times, right? It's expensive, exactly. So what happens, by the time thread 0 is ready, spawned up and ready to execute the run method, by that time main method moves forward and executes line number 3. That is why what happens, you get line number 1 getting printed, then you tell a new thread that okay, you go and print 2. Till the time main thread will print 3 and then 2 will get printed. That is why you see 132, 132, 132, 132. A lot of people said that it is not possible to predict the output of a multi-threaded code and it is always going to be random. You are right. You are correct. But you have to understand, this is not something very tricky. This is not something very heavy in machine, like multi-threading and all. This we can predict. At least something we can predict. I totally understand that we cannot predict multi-threading output and I'll show you that as well. But this we can predict at least. Okay? This is good. This is clear. Okay? This is clear. Yes, Neha, it's not possible. We also don't know how, we also don't know that whether CPU will execute that thread first or this thread first, or what if CPU puts thread main on pause and executes thread 0. We don't know. But here it's more or less we know it's going to be 132. Right? Now, let's move back. Let's move forward. Now let's move forward. Let's go back to the code and see something that we have discussed. Okay. There's a problem. The problem is if I go to this hello world printer run method, if you see the runnable, right? If you see the runnable interface, it has one method called public abstract void run. Now, question is there any parameter in the run method? Is the run method accepting any parameter, any arguments? No. Is the run method returning anything? No. So it is not taking any input, it is not giving any output. Bit problematic, isn't it? Bit problematic, right? So let's imagine I want to print numbers from 1 to 100. Let's take assignment number 2 for today. Let's take task number 2 to understand this further. Let me go back to my iPad. If you all can see, let's take assignment number 2 that I want to print numbers from 1 to 100. Okay. So let's take that assignment. Do you want to print numbers 1 to 100? Print numbers 1 to 100. Pretty easy, right? Printing numbers 1 to 100. Is it correct? Pretty easy. But do you think that I'm asking you to print it with a single thread on main thread? Just write a for loop and print 1 to 100? No. You have to print each number. Print each number on a different thread. Print each number on a different. Okay? Okay? You have to print all the 1 to 100 numbers on 100 threads. So we'll create 100 threads. But the problem is, how do I tell that thread to print the number between 1 to 100? How do I tell that thread? Because is your run method accepting any parameter that you can pass that parameter and the run method will print it? No, right? Exactly. So what we will do to pass a parameter to the run method, okay, we cannot pass parameter to the run method, but can we create an attribute for that task class? Create an attribute for the task class. And then can you pass that attribute value as a constructor? Can we do this? And then we can use this attribute inside the run method. Can you do this? Can you pass this attribute inside the run method? Yep. Let's see how we can do this. Let's see how we can do this. So let me go back to IntelliJ. Visible? IntelliJ visible to all of you? Okay. The step number 1. What is the step number 1 to do any multi-threading task? What is step number 1? Create what? Task class, right? So let's create a task class. So let's call it number printer. Implements runnable. Okay, we will implement the runnable run method. Some of you had questions on this override keyword. I'll discuss it with you. Don't worry. I'll discuss what is this override keyword. But I need to pass a number. I cannot pass a number here. If I do, let's say int x. See, do you see an error coming up? Do you see this error coming up? All this red color. So I cannot pass this int x. Not possible. So what I'll do, I'll create a private int n. This is the number. And I will create a constructor here with this int n. So what I can do is that I can pass this n as a input for this number printer object. And then I can use this n here. So what I'll do, I'll print out the number. The number that I'm printing is n, and the thread that I'm using is current thread dot get name. Okay? So if you see this code, what I have done, instead of passing an input to the run method, I have passed an attribute to the class, and this attribute is getting initialized to the constructor, and I'll use this attribute inside my run method. Is this thing clear to all of you? Is everybody clear about this code? Can I get a yes or no from all of you? Can you all quickly give me a yes if you're all clear on this? Quickly, I want to let's test the yes button. Let's see if it is working or not. If it breaks or not. Okay, awesome. Now let's move forward. By the way, those of you who are worried about what is this override annotation? Anybody knows what is this override annotation? So this override annotation you give or you don't give doesn't matter. You put this annotation, you don't put this annotation, doesn't matter. The only task that it does, it's like increases the readability. Like anybody who will be able to see this method, they will understand that okay, this is an overridden method, increases readability and keeps a check. Okay. Like keeps a check as in like whether you are actually overriding or not. For example, if I put an int x, am I overriding it, everyone? Because in your parent method there is no parameter, but here you are putting a parameter. Is it overriding? No. That's why this is the case. Okay. Any if you have already something which is the language providing, why do you need a comment for it? Right. Okay. Anyway, so just letting you know, those who are worried about override annotation, it does nothing. It is just for like better readability and all. Okay. Okay, Shubham, thanks. I don't know whether I should say thanks or not. Or okay, okay, chalo, let's move forward. I'll take because I listen to a lot of Punjabi songs. I'll take it as a compliment. Okay, chalo, let's go back to the main. Okay, now what I want to do in main, what I'll do, everyone, I'll comment this part out. Okay, I'll comment this code out. I'll not delete it so that you guys can have it. Okay. This is the thing. Okay. Now let's move forward. I am not bald yet, Kanaya. Chalo. Yeah. Let's move forward. So, okay. I will share the code. Don't worry. I'll keeping it commented. I'll share the code. I'll give you. It's okay. It's okay. Don't worry. Anyway, coming back to the point, I will not delete the code. I'll upload it on GitHub and I'll share it with all of you. So don't worry. For now, please focus on the lecture. You'll get the code, you'll get the notes, you'll get everything, but focus on the lecture, okay? So I want to print 1 to 100, right? So let's do that. So let's write a for loop. Int I equals to 1, I less than equal to 100, I plus plus, running loop from 1 to 100. Okay. Now let's create the object of the task class. So number printer, let's call it number printer equals to new number printer and pass the number that you want to print. Okay. Now let's create a thread. So thread t equals to new thread. I'm passing the number printer here, and then I'll do t dot start. Okay. So do you see what I'm doing? I'm taking numbers 1 to 100, creating one object for each number, creating one thread for each number printer, and then starting the thread. So let's run the code and see what happens. All printed. But do you see there's one problem? Okay, let's first see that are the numbers completely have we printed all the numbers? So I think we have printed all the numbers. 2 is there, 7 is there, 100 is there, I think 100 is there. Anything else? I think every number is there. All the numbers are there. And do you see each number has its own thread? What is the first thread that starts? What is the number of the thread first that starts, everyone? 0. Correct. 0. So thread 0 should be there. Thread 0. Yeah. Do you see thread 0? So it starts from thread 0. Every number has its own thread. Do you see thread 4, thread 7, thread 38, thread 32? Every number has its own thread. Every number has its own thread. So you have total 100 threads. Thread 0 to thread 99. We have 100 threads, one for each number. The question is, Sandeep, you passed the numbers sequentially. You took 1, then you took 2, then you took 3, then you took 4. But the question is, why are the numbers coming output as jumbled? Why are the numbers jumbled? Why are the numbers jumbled? Yes, you cannot predict, because every time I will run this code now, it will come differently. See, it is right now coming at 30 in the top, right? Let's run the code and see what comes at top now. See, 8 is at top. Let's run it again and let's see what happens. 25 is at top. 9 is coming after that. Okay, let's run it again and see what happens. Okay, 45 is at top, 40 is at top. Okay, let's see when it is. Now 24 is 20. So it's completely changing. It's completely random. We are not able to tell what is the output, right? So the question comes is, okay, fine. I mean, we cannot predict it, but why? What is the scenario? Let's see. See, in our hands, we have the capability to tell the CPU or tell that, okay, hey, you need to do this. You need to break these tasks into these many threads and you need to execute. But we cannot tell the CPU or we cannot tell the processor that you execute this task first, then this task, then this task, then this task. That is somewhat possible, but you cannot completely control the flow of the execution. That is not possible. Okay, somewhat possible. You can set priorities, you can do sleep, you can do joins, you can do a lot of things, but like you don't have direct control on the CPU's execution. Okay? So what is happening here? Let's understand. Let's take the code. Let's take the screenshot of the code and let's come and see how the flow is working here, right? So what I'll do, I'll take the screenshot of the code and let's see how it works. Tell me if you guys can see this code on the screen. What do you see right now? Do you see the iPad? Yes, awesome. Okay. See now, which thread will run the for loop? Which thread will run the for loop? Main thread, exactly. Now, the object creation is done by main thread. The thread creation is done by main thread. But the moment you call start, so what happens? In the beginning, you said, okay, start for number 1, start a thread for number 2, start a thread for number 3, start a thread for number 4, start a thread for number 5. Now, the point is because main thread is consecutively running, right? Because the main thread is consecutively running, because the main thread is running like continuously, there is no break. By the time the thread 0 starts for number 1, it might have already created multiple threads. By the time T1 starts executing, it might have created multiple threads. Now, the moment I have multiple threads waiting for execution, it is up to CPU how the CPU will execute them. Okay? Because the main thread is running very fast and there is no pause or there is no sleep or there is nothing like that in the main thread. It is creating as many threads as possible, right? It is creating for 1, 2, 3, 4, 5, 6. But the moment it is ready to print 1, at that time multiple threads are already created. Because multiple threads are already created, it is up to the CPU scheduler who will take care of that, who will execute next. Exactly. CPU is the boss, right? CPU is that saliva, right? So that's the thing. So CPU is the god of everything. So you can tell, okay, I want to do this, I want to do that, but the execution order, the scheduling of each threads is handled by something known as scheduler in processors, and that is what takes care of it. So it's a combination of OS and CPU. It's not just CPU. I mean, CPU is just a hardware, right? So it's a OS which is running on CPU. So combination of both which takes care of this. So this is how it works. So that is why it is random. We don't know what will happen. Because till the time you have to print one thread, you have already created multiple threads and it's taken up by that. Okay. CPU means processor. Please just CPU means a bigger thing, but for now just understand processor. Yes, you can do a lot of things with it. You can, if you want to make it sequential, you can do it. You can put a sleep that, okay, after every thread creation, wait for 2 seconds. So let that thread create and print the number. That we can do. Not a problem. That will print it sequentially. But this is what happens in general. Clear? Now I am on a MacBook M1 Pro. Can somebody tell me how many cores are there in M1 Pro? Anybody knows how many cores are there in the M1 Pro CPU? 190, 832, 8 maybe 10. I also don't know. I think it's something around 10 or 12, something like that. But whatever, it's not 100. It's less than 20 for sure. I don't remember the exact number, but it is less than 20. So if since I have less than 20 cores in my laptop, how am I able to create 100 threads? 10 cores, right? Okay, fine, 10 cores. So how am I able to create 100 threads? What did I tell you? Is you can create as many threads as you want, but execution depends on core. You can create 100 threads, you can create 200 threads. It depends on the core. As simple as that. Okay, that's what it was. Cool. How many cores are there in a typical supercomputer? I don't have a supercomputer enough, so I don't have that idea. Just Google it. This is simply Googleable question, right? So that's the thing. No, generally they don't. I mean, Intel has that hyper-threading thing where 2 cores act together as a single core and they multiply the number of threads. So that is what happens, but it is only for that pair. It's not like you can jump through. Okay. So coming back to, so everybody is clear about multi-threading, execution, how it works internally, all good. I hope everything that we discussed till now is good. Before moving forward, I have to discuss one interesting thing with all of you. Something very interesting that I want to talk about. Do you guys know about a company called SpaceX? How many of you know about a company called SpaceX? Elon Musk? Okay. why is it famous? Why is SpaceX famous? Why is SpaceX so revolutionary, or is it famous? Reusability. Exactly. Reusability. Okay. So the concept is that, okay, the concept is simple that uh, if I take one rocket to launch a satellite, right, and I destroy that rocket and put it somewhere in the Bay of Bengal or somewhere in some ocean or outside of the world, each satellite launch becomes very expensive, right? Because I have to build that rocket, it will take time, it will take money, and every time you create a rocket, you ship it and you go into it, right? The better use case that SpaceX brought is that, hey, don't do that stupid thing. Don't create the rocket and destroy it for every launch. Reuse it. So your rocket goes, it puts the satellite back and the rocket comes back, correct? The rocket comes back, right? Yes? Okay. Same thing here. Creating a thread is an expensive affair. You just saw, right? You remember that example of 132, where the main thread was able to print 3 before the other thread got created and printed 2. Do you remember that's 132? I told you, na, creating thread is an expensive affair. So if I'm multiple times creating threads, destroying them, creating thread, destroying them, is that a good idea? Is that a good idea? No, it's not. So we need to bring something as a reusability here. We need to bring reusability, and we'll talk about reusability. So I'll tell you one scenario. Okay, I'll tell you one scenario. It was very, very early in my career. So by the way, how many of you, like when I told you about my transitions from Capgemini to Agio to Visa to Atlassian, do you know I was actually a Scalar alumni as well? So my transition from Capgemini to Agio happened, like I was in Scalar at that time. It happened via Scalar. So anyway, coming back to the point, what happened is that I went to Agio and I was working there. Now Agio being an e-commerce platform, fashion e-commerce, and I joined there in Kaushik. You can go and check Scalar's website. You'll find all my details there in the alumni section. Okay, so it might not be there in my LinkedIn, but yeah, it's there. So coming back to the point that when I was in Agio, right? So what happened is that I was working on an e-commerce platform, microservices architecture. I was working on the supply chain part. Supply chain as in like the services that take care of shipping, billing, all these things, right? Of your products, maintaining the inventory and all that. So it was part of that system. Now I knew about multithreading a little. I studied in Scalar. I knew about multithreading a little, but the concept that I'm going to talk about right now with all of you about the rocket reuse and all that, it is called something known as an executor framework. I had no idea about executor framework. So they told me that, okay, Sandeep, you need to, I'll tell you what the use case was. The use case was to check the government portal. When you're shipping products, you need to have some road permit and tax and all that. Okay. So they were saying that while you're like going through the inventory, parallelly check that, okay, check the government website that, hey, I mean, what is the tax and all for this? And that was the scenario. Okay. So what happened is that I wrote the code. They told me, no, do it on multi-threading because the government website is very slow. Till your one thread is calculating the inventory and all that, use that other thread to go ahead and like sort of calculate from GST and whatever is required. Okay. So I was like, fine, I'll do that. I did that. I created threads the same way I told you right now, created threads, thread.start and all that. But at that time, actually, I got placed a bit early. I did not complete my course and I did not go through it. I did not know about this executor framework thing. And then they told me, you don't know about executor framework. It's something, so we don't create threads on our own. We never do that. We always use something known as a thread pool. I'll talk about this in the next few minutes. But I was like, oh, okay, this is what. So it took me a lot of time. Right? It took me a lot of time to learn those things because I went from Capgemini. There is so much you can learn and you can do from a platform, but day-to-day work matters a lot, right? And also it was way back in 2020. This first COVID wave hit. That times DSA and all was like the thing. Like you do DSA, you are hired. Like everybody was crunching lead code. Everybody was doing 400, 500, 600 DSA questions, and they were getting hired and they were getting very good packages and all that. But if I look back into that history and if I look into the current market right now, I see it has changed drastically and it is changing for good. And it's changing for good. So if I just talk a little bit 2 minutes about the market and the job and everything right now, what you will see is that if I talk about 2019 to let's say 2022 Q3 till this time, all the companies were hiring on basis of future requirements. So okay, I will need 10 engineers 3 months down the line. Let's hire them right now. Okay, I will need 60 engineers because I'm going to create a new product. Let's hire them right now. So they were hiring based on future requirements. Okay, future requirements. So my company will scale so much. Let's hire them right now. Now what is happening is that now you are thinking that way. Let's say I am at Meta. I am thinking that okay, in the next 6 months my business will grow and I'll need 100 engineers. Similarly, Google is thinking the same. My business will also grow. I will also need 100 engineers. So if I don't hire them right now, Meta will hire them. So Meta thought, okay, Amazon also thought that. So it created a scarcity of engineers. Everybody was like hire. It created scarcity of the resources. Now that is okay, that is good for us. I mean, for us employees, we are getting more job opportunities, better packages. But the problem at that time was because they did not know where I'm going to. Let's say Meta hires Sneha right now, let's say Google hires Shivam right now, they might not know exactly in what team and what tech stack they will be working on. They might not know that okay, if I hire Shivam right now, 3 months down the line, which project Shivam will be a part of, right? So they used to hire based on the problem solving ability. So they were like, okay, let's ask Naveed a lot of questions. Let's ask Abhinav a lot of questions. Let's ask Annie a lot of questions in DSA and hire them. We don't know whether they will work on Google or they will work on Python or Java or Node.js and all that, right? They did not know that. So they did not check on your development capabilities, how good you are in developing things. Now that has changed completely. Now companies are not hiring based on future requirements. They are not hiring on a buffer. They are like, dude, you need to join the company as soon as possible and you need to be productive from day one. I need you to start working from the week 1 itself. So now they're hiring on present requirement and not just present requirement. It's like core, like if I need, then only I'll hire on need basis. There is no hire on predictability. There is no hire on future requirement. There's a hire on need. If I need an engineer, then and then only I'll hire. I'll think 10 times before that. So what that has made is that now because the companies now want you to be productive from day one, if it is a Java role, they will not hire a C++ person by asking them DSA. If it is a Python role, they will not hire a Java person by asking them DSA on Python, right? The thing is simple. DSA is still there. DSA is not going out, right? DSA is not going out, but what I am saying is that the weightage of DSA is going down. You cannot just say that I have solved 500 lead code questions and I'll crack an interview and I'll get a job. No, those are gone. DSA is still 1 round, 2 round, but the importance has gone away. Now what they are doing, they're focusing a lot more on design plus your ability to do development. How good are you in developing things? Are you able to make projects? Have you made your own projects? Have you made your own personal projects? So because of this, what we did, because we saw this trend changing in the beginning of this year, we actually went ahead and changed our entire curriculum. Our curriculum was previously like extremely DSA heavy because we used to see people are getting placed after doing DSA and all that. But now we saw that, okay, this is changing. DSA is still there, so we cannot skip DSA. DSA is something that we cannot stop, but we have actually updated the entire curriculum for that. So what did we do? Let's see. Let me show you a little bit on that. So what we did is that, okay, let's make it more towards handhold development. Let's do it more towards, build things and all, right? So let me show you something. I don't know if I can show you, but I'm just showing you because you are all here. You guys can go through this. You can, if you want. So basically, if you see, right, we have built things from scratch now. So what happens is that we have 2 tracks, backend and full stack. We go through all the object-oriented concepts. I don't know if you're able to see this or not. I'll zoom in a little bit more. So we go through the object-oriented concepts. We go to the concurrency concepts like multithreading. You see, we are discussing this in we are discussing multithreading in a 2.5, 3 hour lecture, but we have actually 4 lectures on concurrency, right? 4 lectures. Then we have advanced concepts in Java. Then we go to the design patterns. So we cover almost 12, 13 design patterns, which is almost a lot. 90% covers 95% use cases. Then we build projects. So you see, we build a game called tic-tac-toe. I don't know if you guys have played tic-tac-toe, but we build a tic-tac-toe. We create parking lot. We create book my show. We create splitwise. We create 4 projects just in the machine coding module. Okay, just in the machine coding module, we built 4 projects, and then we have a full-on project that we built. So if I show you that, let me go back to the project. Let me. I don't know if I should show you or not. By the way, we are still covering DSA. Don't worry about that. DSA is still there. We cannot just stop doing DSA. But let me show you the project module. The project module is very interesting. If I can show you that, what we are doing in the project module, I'll just take 2 minutes just to give you an idea of how like we have built things and how we have broken things down. So yeah, so if you see here, right? So we've integrated all the design aspects and we are building the project from scratch. So if you see this, everyone, we discuss backend module, version control, basically Git and all that. Then Linux, we talk about the Linux and everything, how it works on server and all. Then we talk about Spring Boot. We have other MERN stack tracks as well. I'm just showing you one of the tracks. We have multiple tracks. We then talk about REST APIs. We talk about APIs, Swagger, RPCs, remote procedural calls. I don't know how many of you know about RPC. Do you know about RPC? gRPC, Google RPC. Anybody knows about RPC? Heard about this term before? One of the raging tech thing in the industry right now. It's so advanced that people have not even heard about it. So anyway, data persistence. We talk about JPA, ORMs. We talk about advanced Java operations. How do you do database migrations? If you have to do, let's say you are working in a company, you joined, let's say Walmart, and Walmart told you that, hey, we want to move from MySQL to MongoDB. How will you do that? So DB migrations, unit testing, authentication middlewares, paging, sorting, Elasticsearch, one of the most needed thing for any developer. How do you create microservices, cron jobs, Kafka, using Kafka, MongoDB, NoSQL, Redis, monitoring, Dockerization, AWS. So this is complete. We build one project covering all these topics. That is almost 20 some like that is what we do. So the point is that we don't want you to just crack interviews. We want, if you are learning from Scalar, you should be an all-round developer. You should be able to crack any kind of interviews. We cover DSA, we cover low-level design, we cover high-level design, and we dedicatedly do all these things to make you an all-round developer, right? So that's the thing. If you are interested in this, if you feel that, I see a lot of questions coming in. There are so many tracks, by the way. There's a beginner track, there's an intermediate track, there's an advanced track, there's a Java backend track, there's a MERN stack, full stack track. There are multiple tracks. I cannot show you all of that and waste the time right now in the class. But if you want to know more details about the tracks, you want to know more about the cost, you want to know more about the timelines and other benefits that Scalar provides to upskill yourself, we will launch a callback poll right now. Just drop a yes on this. Somebody from the team will reach out to you, will give you every detail. You take their time, you ask them as many questions as you want and get a one-to-one with them. For experience level tracks also is there, Rahul. So we have 3 tracks, beginner, intermediate and advanced. Depending upon where you stand, we will allocate you that particular track. So it's not like one size fit for all. That's not going to work, right? Annie, I never said that we are not teaching DSA. We are teaching DSA. The only thing is that as per the industry has changed, we have also like updated our course and we are also focusing a lot on development side as well. So our major goal is that to make you an all-round developer. Like you should be someone who, trust me, I know this, that in the industry during this 2020, 2021 time, a lot of freshers specifically did a lot of courses from all the Bhaiya Didis on YouTube, crunched lead code like anything. Right? 400, 500 questions. I have no idea about building a simple project. If I ask them to build a simple parking lot, they will not be able to build. But if I give them a very tough tree graph DP question, they can do it. It's good. It's a good skill set to have to solve those problems. But if you're solving DSA problem, you're doing it to build a project, to build something on scale, to make something more performant. If you don't know that, then what's the use of DSA, right? So knowing DSA and applying it are 2 different skills. So we want you to have both the skills. You know DSA, you know design, and you know how to apply them. And that's what companies are looking for right now as well. They don't want to hire you and give you 2 months to train. They don't want to hire you and give you 1 month, 2 months to learn this, learn that. No. Join the company, start from day one, start from the first week itself, right? And that is not just for startups, that is for every company, right? So that's the thing, folks. Like giving you, like just mark a yes on this. From here, I'll think Sonajyoti is here. Sonajyoti, you can take it forward. What we will do, I'll take a short break. Sonajyoti will be here, continue the conversation with all of you. We'll come back and we'll discuss about that rocket wala example that I talked about. Okay. So Definitely, Rajesh, we are never saying that you do it for interview or a switch. It's to become an all-round engineer. That's your job. So get some insights. If you feel it's beneficial for you, please move forward. If you don't feel it's beneficial, it's okay, not a problem. Cool. Okay, Sonajyoti, over to you.
Thank you so much, Sandeep. You can just take a short break of 5 minutes and drink up some water as well. In the meanwhile, guys, I have some few important links to share with you before Sandeep takes up here. So we have got a free class coming in from Anshuman Singh. Now for all of you just who don't know about Anshuman, just to give you a heads up here. He's currently the co-founder of Scalar, and he is also one of the founding members when it comes to Facebook Messenger app as well. So let me just paste the link for that here for all of you once again. So like this particular session will be very short and dynamic session, like consisting of very less number of people. So the main idea of this particular session is so that we are focusing on your questions on a more priority basis. So that is where if you have any sorts of questions regarding your career aspects, or like in terms of any, if you're planning to crack any sort of big tech companies as well in terms of the interview structure. So here in this particular session, Anshuman will talk about how to crack high numbers when it comes to the different tech companies as well, how to revamp your different resumes, how to speak and present yourself when it comes to the different SD companies, top tech and SD companies interview structures. So that is where Anshuman will be helping out for the same, and his team would be there as well. Cool. With this being said, I have other things, important things to share with you as well. Just give me a second. So guys, for those of you who missed out to connect with Manideep or Bhaskar, this is again a type form that wherein you can submit all your questions and query regarding your career and current aspirations. If you're stuck in terms of your career, you can just place all your details here and the team would surely get back to you on the same. Again, reiterating, the best part is that you'll be connecting with the alumni in a one-on-one format. So don't worry on that part here. Once again, any books for system design? Rajat, if there are any particular resources that Sandeep feels to share, he will surely share at the end. So don't worry on that part here. Moving on. Now, a lot of you were asking, like, where can I connect with like the different people here who are joining in Scalar? If I can connect with someone who has been an enroller or something like that, what you can do is that you can join our community here. You can join our coding communities, you can join our Telegram groups as well. So I will just quickly paste the link here. So if you want to have like in this particular communities, you can find many SDs, many data scientists are already a part of it. So if you want to collect all the notes, if you want to be a part of different fun activities that is being already happening there, so you can just join in this particular link as well. We will be also sharing the notes here as well. So don't worry that part. Ganesh, if you want to understand on the cost perspective, if you want to understand on that figures, salary figures or something like that, if you have clicked on yes in that poll itself, which Sandeep has launched, the career team would be reaching out to you, wherein they will be helping you in terms of understanding what would be the scholarship that will be provided, because there is an entire format you have to pass on when it comes to going forward with the particular program. So you have to crack a particular scholarship test, then you will be understanding what will be the fee structure and everything. So entire thing will be shared from the career team itself. So if you have clicked yes, definitely you'll be getting a call to understand the same. Moving on again. Now, a lot of you were inquiring regarding, you want to understand like where you can get the notes and whatever Sandeep is sharing throughout this entire session. So I will just quickly paste the WhatsApp group link here itself. So please kindly join in this group immediately, guys. Just flood in right away so that whatever questions or doubts you are having, like whatever questions, doubts or anything, just ensure that you are putting up in the questions tab. Make sure, like whenever Sandeep is taking up any questions, he will post that. But in the meanwhile, just flood in into this particular WhatsApp group. Ensure that you are getting your notes as well. Cool. Events page. Okay, I will just quickly share the events page link for all of you as well, so that if you want to check out for any sort of upcoming master classes as well, okay, you can just quickly go on to this particular events page, but you can just have a look like whatever the upcoming master classes, or if you want to join any particular topics as well, you can just surely look on to that. And for the certificate, many of you were asking like, how can I get the certificate? How can I download that? I will just quickly attach the link for that particular certificate where you can get here. So it is the same link where you have registered for this particular event. Just click on this link tomorrow at around like 11 a.m. sharp, wherein you can be you able to download this particular certificate on that same link itself. So take some, like, it will be taking some time, so like don't rush up. There's many were asking like, how can I download the certificate right now, something like that. It will be taking some time, so you can download the certificate by tomorrow by around 11 a.m. Cool. With this being said, I believe Sandeep has joined in the session. So Sandeep,
Yep.
if you have joined in, you can take it over from here.
Awesome.
Cool.
Thank you.
Over to you.
Thank you, Sanjati. Just give me a few seconds because. Okay, just a second. Sorry, folks.
Guys, there might be some issues from Sandeep's end. He is joining in soon.
I am back.
Cool.
Just a minute. Okay, awesome. Cool. Let me know if you guys can see my screen. Something went wrong. The screen share got stopped. Just let me quickly. Yes, Mehil, I am standing. Like setting the entire day becomes a bit difficult with the back. So I need to stand and sit. Okay, just a minute, folks. Yeah, let me know. Screen is visible to all of you? Yep, okay, awesome. Sure, yeah. Let's move forward. So, coming back to the point, rockets, right? Rockets. Okay, so SpaceX, reusability of rockets. How can I reuse threads? So there is something called as Executor framework in Java. Okay, Executor framework in Java. Okay, so what I will do, see, when the SpaceX came into the picture and the cost, because they were able to reuse the rockets, the cost went drastically low, right? The cost became drastically low. Now, because the cost became drastically low, they were getting a lot of orders, right? They're obviously getting a lot of orders, but they cannot fly everything at the same time, right? So they need to maintain the orders that they have. So like the way the SpaceX has to maintain an order, Executor framework also maintains the task that comes to it. So basically, Executor framework has two major components inside it. What are the two major components? One of the component is something known as a work queue. Something known as a work queue. So this queue basically maintains the tasks. So if I'm giving it tasks, it will maintain the tasks. If there is no thread available right now to get the task, it will wait in the queue. So tasks will wait here. So let's say task 1, task 2, task 3, task 4, task 5, so on and so forth. The tasks will wait on the queue. Okay, cool. Now, what happens in the other component? The other component is the major exciting part that we call something known as a thread pool. Thread pool. Okay, what is this thread pool? Thread pool is a pool of threads. So what it does, it creates the threads and keeps them ready for use. So let's say if I have 5 threads, what it will do, it will assign one task to each thread. So it will assign, let's say, task 1 to this thread. This thread is now blocked. Then it will assign 2 to this thread, then 3 to this thread, 4 to this thread, 5 to this thread. Now when T6 comes, if there is no thread available right now, T6 will wait in the queue, and any of the thread once they become available, right? Any of the thread once they become available, let's say T3 completed the task, this thread will not get destroyed. This thread will not be destroyed like the old way we discussed. the thread will come back to the thread pool. So then this thread will pick up the task T6. So this is what Executor framework does. Executor framework maintains a queue of the tasks and maintains a pool of threads and reuses those threads again and again. It will not destroy the threads, so that if I destroy the thread, I need to recreate them, and recreation of threads are expensive. So I will reuse them again and again. So basically, Executor framework has two major tasks. One that I talk about right now, reusability of threads. And maintaining queue. Apart from that, it does one more thing for us. Now, since we are not destroying the threads and all these things are gone, the thread creation headache from the developer is also taken away. So I don't need to worry anymore about creating the threads and starting the thread and all that. So Executor framework takes care of thread creation. Okay, all these things are taken care by Executor framework. So the point is very simple. In the queue, I have tasks which are waiting. Threads are there. The task will be assigned to the thread. Thread will go back and get the job done. As simple as that. So if I see the normal flow, right? So if I see the normal flow, what we have discussed till now, what have we discussed in the normal flow till now? Let's say you have a task. So you have a task. So there is a thread that you create. This thread takes a task, right? Goes to the core of the CPU, executes and completes. And after execution, this is destroyed automatically because we are not using the thread object anymore. It gets destroyed. Okay, it gets destroyed. Now the next thing, thread in the thread pool. Now if I talk about Executor framework, if I talk about Executor framework, what happens in Executor framework is that you have a thread which is available in the thread pool. First of all, if there is a task, the task waits for a thread. If a thread is available, then this task starts like thread assigned once the thread is available. After that, the thread goes to the core, thread executes, and instead of destroying, it goes back to the thread pool. Goes back to thread pool. So you see, every time I don't need to create a fresh thread. I don't need to do that. Okay. So let's jump onto the code and see what happens. Okay. Let's jump onto the code and see what happens. Okay. So everyone, let's come back to the code. Let me know if you guys are able to see GC, Vasant. The thread object is destroyed by the GC. Can you guys see my screen? Are you able to see the IntelliJ, folks? Able to see IntelliJ? Awesome. Okay. So now this task that we did with 100 threads, not a very good task, right? Not a good idea is using 100 threads because obviously garbage created. So using 100 threads, you are unnecessarily creating 100 threads, right? The laptop has 10 cores. So why would you create 100 threads? I mean, doesn't make any sense. So what we will do, let's comment this part out. We will achieve the same task using Executor framework. Using Executor framework. So what I will do, I'll create an Executor framework for all of us. And just give me a minute. Yeah. So what I'll do, I'll create an Executor framework for all of us. So we'll create something known as Executor service. Executor. Okay. Executors dot new fixed thread pool. Now, how many threads do you want? Tell me, how many threads do you want? So in general, the count is 2 into number of cores, but for now, let's keep it 10. For now, let's keep it 10 because CPU is also like OS is there, browser is there, so many things are there. Let's keep it 10 threads for now. I have 10 cores, I have created 10 threads. Okay. Now I will start the loop. Loop for int I equals to 1, I less than equal to 100, and then I plus plus. And now what I will do, I will create the task number printer equals to new number printer with the number I. Now this task, I will not be worried about. I will not worry about the thread creation and starting the thread. All I will say, executor framework. This is the task. Do it and execute it. I will submit this task to the executor framework. That's it. I'm done. That's it. So basically created the task and gave it to the executor framework. Now creating thread, starting the thread is not my headache anymore. These two lines are not my headache anymore. My headache is here. I created the executor service and I'm done. Okay. Now let's run the code and see what happens. This was the code with the previous thread one, right? Let's run the code now. What happens? Let's see. So if you see here, in executor framework, by the way, the count starts from thread 1. So how many, like what was the size of the thread that I told? 10. So if you see, what is the maximum size of the thread? Thread 10, thread 10, thread 10, thread 10, thread 10, thread 10, thread 10. And do you see the pool also coming in? I told you, it is part of the thread pool. So there's a thread pool, pool number 1, thread 10, pool number 1, thread 5, pool number 1, thread 6. Cool. Yes, this is completely predefined. I have just called this method new fixed thread pool and give it a size 10. Okay. Yes, you can make multiple pools as well, but we'll not go that there. It's actually required for very big applications. Generally, you don't need multiple pools. You can do it with single pool as well. Okay. So you see that we printed the 100 numbers now using 10 threads. But let's go inside it. Let's see how it actually works. So what I'll do, I'll put a debugger here. If I is equal to 11 or I is equal to 51 or I is equal to 100. Let's put a debugger. Okay. Let's print something. Let's say hello. Let's put a debugger pointer here so that in the for loop, when I becomes 11, I want to see what happens. Okay. In thread pool Danica, it starts from 1. In thread pool in executor, it starts from 1. Okay. Now, okay. So my debugger is here. My I is currently at 11. That means how many I of them are executed? Everyone? How many times, like how many numbers are executed as of now? If I is at 11, how many of them are executed right now? 10. Okay. So let's open the executor and see what happens. Can you all see this executor? Okay. What is the size in the work queue? What is the size in the work queue right now? 0. That means, is there any task pending? Is there any task pending? No. Nothing is pending. Why will it be pending? My thread size is 10. I've given 10 tasks. So should it be in waiting area? If you have given 10 threads and there are 10 tasks, should there be any task in the waiting area? No. Okay. Now if you see the workers, worker is basically the threads. Do you see 10 threads here? These are each threads. These are one of the threads. Now if I open them, do you see thread pool, thread number 7? You see each one of them is thread and each of them have the task inside this, the printer task they have inside it. Okay, if I go inside this, I should be able to see somewhere the task is there. Just a minute. Somewhere it should be there. It should be somewhere. See, pool 1, thread 6, there's a pool number, thread number is going in, but the task is inside this. Okay. Now. Let's see further. Okay. Now let's see further. Let's see it further. Now I have 10 threads. All of them are working. No problem. Now everyone, I'll run this code. I'm at 51 now. So when I'm at 51, how many numbers are like, how many number printing tasks are given to the executive framework? How many number printing tasks are given to the executive framework? Tell me. 50, because I'm at 51, 50. So if it is 50 and I have 10 threads, how many tasks should be available in the worker queue, waiting queue? How many tasks should be there in the waiting queue? 40, right? Because I have 10 threads. So 10 of them have picked it up. It comes here. So do you see the worker queue has 40 and I have 10 threads? 40 plus 10, 50. I is at 51. So you can understand we have submitted 50 tasks. If I open this, again, this will internally have the work. See, do you see wrapped task number printer at the rate this? This is the object, the particular number printer that you want to do. See, number printer 1029 is the actual one. Number 11 is getting, is. Do you see this, everyone? Do you see the task in our queue waiting to be executed? Clear? Similarly, when I'm at 100, I is equal to 100, how many tasks you have executed? 99. So 10 are at worker and 89 are waiting. And the moment I complete my submission, the moment my submission completes, everything gets printed out. Is it now clear that how Executor framework maintains the pool and the thread pool and the tasks and everything, the waiting queue and the thread pool and everything? Is that clear to all of you? Can I get a yes or no from all of you? This is how you should debug. This is how you should stop the code and go internally. Just open things, open things. The moment you do debugging now and the moment you start reading internal code, you automatically become a very good developer. So for example, let's say somebody wants to know, I want to do this thread pool, just go inside this code and read this. Read what it does. Go inside the implementation and see what it does, right? Read these statements. It will give you a very good idea, okay? But that comes after some fundamental knowledge. You cannot just directly do it. But I hope you got this point, right? Okay. So Tejas, until you don't end up submitting all the tasks in the executor, executor will not start executing it because the for loop was running. It knew that submission of tasks is going on. That's why. So the moment you come out of the for loop, it starts executing. That's why it was blocked. Okay. Cool. I hope clear, everyone. Okay. I'm really sorry, folks. I'll not be able to repeat the entire thing again because we have time limit as well. Those of you who are part of Scalar or would join Scalar will get the entire recording. You can watch it again. But because we have to cover a lot of things, I'll have to move forward. So I hope you understand. Please put more focus. I see focus. Some people are missing their focus. Just focus a bit more. Okay. I'll give the code. Don't worry. Code will be given to you. Code and notes both will be given to you. Okay. No, executor, like you can have to destroy the executor if you want. So executor dot, I think shut down. Yeah, here's the method. This is the method that destroys the executor if you want to destroy. Okay. This is the thing. Okay. You can have multiple executor services. Yes. Okay. So it is clear now how we can reuse threads. If that part is clear, I want to jump onto something more super interesting and something that I have seen a lot of industry people also not understanding well. If you are all clear on this, can we move forward to something more super interesting? Okay. Okay. Please focus. Please focus. This is something very, very important and this is something very good. So my question is, if I dial back to the statement that I told you when I was working in Agio, let's say you are going to buy, let's take a simple, let's say you're going on any e-commerce platform. Okay. Now let's say you saw a product. The moment you see a product, the price that you see, right, has three important factors. Number one is the actual cost of the product, has the the tax on the product, the discount on the product, and the delivery fees. Correct. Now the cost and the tax can be pre-computed because the cost of the product is same for everyone. The tax is also same for everyone. But the discount on the product and the delivery fees of the product is individual, because if you are a very good customer, I might give you more discounts. If you are a customer which is coming back from after a long time, I might give you more discounts to make you purchase. So discount is based on the customer, delivery fees is based on the customer. But when I show the final price to the customer, the final price, I need all these four things. Should I execute them one by one? Should I first calculate the cost, then calculate the tax, then calculate the discount, and this calculate the delivery fees? Should I do these things four sequentially, one by one? Or should I do them parallelly, add them up together and give it to the user? What should happen? Together, exactly. So let's imagine we discuss that, okay, let's take these two things at one go. So let's use one thread to calculate the cost and the tax, thread one. Let's use another thread to calculate the discount based on the user history. And let's take another thread to calculate the delivery fees based on the user's location. These three things should go parallelly, right? And then this thread should return back the cost plus tax. This thread should return back the discount percentage. And this thread should return back the delivery fees. And then I will calculate the final price. But the problem is, we saw while implementing multi-threaded code in the run method, is it possible to return anything? What is the return type of run method? What is the return type of run method? Void. Is it possible to return anything in run method? Not possible. So what do? So we have something called as a callable interface. We have something known as a callable interface. Similar to runnable, we have callable. Now, what is this callable? Callable gives you the option to have a call method that returns something. It is very, very similar to your run method, does the same thing multi-threaded way, but gives you the option to return something. Okay. So basically how it works, let's say I have a main thread. Let's take a simple example. Okay. Let's take a random example. Let's take an assignment to understand this better. Like similar to the previous assignments, let's take an assignment number 3. Similar to this, that one thread is executing a number, then you're returning and you're adding and then you're returning. Let's do that same thing. Let's say that assignment is, let's say that we have two threads. Each thread generates a random number. Each thread generates a random number. Okay? Each thread is generating a random number. And they return that to the main thread. And main thread returns the sum. So what you need to do is that you need to have your main thread. Then you'll have to have a thread 0 or thread whatever it is, thread 1. It should generate a random number. Let's say x. It should return that x to main. It should return a random number y. It should return that to y. And then I should print the sum of x and y in the main thread. This is what I want to do. Okay? Simple, very simple. Let's see how it works. Let's jump back to the code and see how it works. Okay? Okay, let me know if you guys can see the screen. Where is the IntelliJ? I'm not able to see the IntelliJ. Can you see IntelliJ now? Okay, awesome. Okay. So let's do one thing. The first thing that you do is that you create the task class. Let's create a task class. So what we will do, we will go ahead and create a task class. Let's call it random number generator. Do you see random number generator, everyone? Okay. What will random number generator implement? Runnable or callable? Callable, because it has to return, right? Callable. Let's do callable. Awesome. Implement the call method. Okay. So what I'll do in this, I will generate a random number and I will actually return an integer. Okay, a random number integer. So random number, we have a random package in Java, in class in Java, and what I'll do, I'll say integer I equals to random dot next int, and I'll return I. Simple. Okay, simple, no problem. And what I'll also do, I'll print it out. So random number generated is I, and what I'll say that this was generated in which thread? The thread was thread dot current thread dot get name. Simple, done. So this is it. Okay. Yes, Rajat. Yes, because it uses generic, so that's why you need to have that one. Okay. Cool. This is clear. Now. There's no shortcut. There's that IntelliJ gives you the shortcut, Abhinav. Like it's clickable. Okay. So everyone, any doubts in this? Basically what I'm doing, implemented callable similar to how we did with runnable. After that, call method returns an integer and generating a random number. This is a random package in Java that you can use. You can see random class. It has a lot of methods. You can generate long, you can generate integer, you can generate anything that you want. Okay. So multiple methods are there. Next int, next byte, next int. You can have multiple things. Next long. So this is an internal class of Java, nothing fancy. It helps you to generate random numbers. Okay. So generated a random number, printing the number and returning the number. Okay. Was this return possible in the run method? Was this return possible in the run method? No. Right? Okay. Parallel, just with parallel. Multi-threading, so parallel, right? Okay. Now what I'll do, I'll go to the main class. Let me comment this part out as well. Okay. So what I'll do, I'll create two task objects because I need to generate two random numbers, right? And how many threads do you need? So I'll say executor service, executor equals to executors dot thread pool. What is the thread pool size? 2, because I need two threads. Thread pool size is 2. No problem. Let's create two task objects, random number generator. Let's call it R1 equals to new random number generator. Similarly, let's create something called as R2. Now, what I'll do, I will submit these tasks, and after submitting the task, they will give a number. So let's say int random1 is equal to executor.submit R1 and int random2 executor.submit R2. It's giving me an error. Why? Why is it giving me an error? Any idea? Achha, it was returning an integer. So instead of int, let's make it integer. Okay. Still giving me an error. Why? Why is it giving me an error? Do you know why it is giving me an error? Let me show you. Instead of integer, what I will say that it gives me a future of integer. Now you will see the error goes away. The error is gone. So what is happening here? And this is giving me error. What is this future? What is this fancy thing future? It's very easy. Something very, 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 very easy. Okay. Let's jump back to the iPad. And trust me, I'm telling you this, a lot of people in the industry don't understand this. I don't know why, but okay, let's understand. Let's see a story. Okay, let's see a story. The story is, let's imagine that you have a friend. Okay. Now the friend's mom or parent are sick, and they need to go to the hospital. Okay. They need to go to the hospital. Okay. Now the friend came to you saying that, hey, I'm arranging for ambulance and a bed in the hospital and all that. I'm not sure how much money I need. I have some cash, but if you have something, can you give me something buffer so it helps me? At that point of time, let's say you don't have money and you are about to get paid. Let's say your salary is about to come or somebody else is going to pay you, or you're going to arrange the money from somewhere, but you don't have the payment with you right now, right? So what will you do? In that case, what you can say that, okay, do one thing, take my ATM card, take my debit card with you. By that, like, will you ask that friend to wait? Hey, wait, the money is coming, or wait, don't go anywhere, the money is coming, don't go and arrange for an ambulance, don't go and arrange for a hospital bed. You will tell the friend, the best solution is, you take my card, right? You take my card and you do all the work that you have to do, right? You go and arrange for whatever things you need to do. You take my card. I don't have money in it right now. I don't have the money in it right now, but I will arrange the money. By the time you reach hospital, by the time you will need the money, I will put something in the account. But for now, just take this debit card and go, right? You go and do your work. So did you actually give the money to your friend at that point of time? You did not. You did not give money, right? You said that, okay, this is a placeholder in place of the money. I'm not giving you the actual money. I'm giving you the placeholder for the money. I'm giving you some sort of a promise that, hey, take this money. When you will need it, I'll give it to you, right? Cool. All good. Now, why the story is coming here? Let's see. Let's say there is a line called x is equal to, let's say in the main method, you wrote a line called x is equal to 10. This will be executed by the main thread, right? So what the main thread will do, main thread will initialize the value of x with 10 and then it will go to the next line, correct? Okay, let's say there is a function called x is equal to square of 2. What will the main thread do? Let's say after this there is some other line of code, more lines of code are there. Let's say main thread is executing this. What will happen here? The main thread will first call the square function. It will execute the square function it can be the main thread, it can be some other thread, whatever. It will execute the square function. It will get the value 4 and it will initialize the variable 4 and then only it will move forward. So if you see, there are two tasks mentioned here in this line. There are two tasks mentioned here. One task is calculation of the square method, calculation of square, and then whatever result you got, you initialized x with that result. Correct? Tell me, just will calculation work? Like just the calculation part work, or will you have to also assign? So that line has two things to do. This line of code means you have to do two tasks. One, you have to calculate the value of this function, and then whatever result you get, you have to assign that value in the x variable. That is clear? That is clear? Yeah, both are mandatory to move ahead. Correct, Shivam. You are completely right. Okay, now let's go back to our code that was giving us error. We wrote that, okay, integer random1 is equal to executor.submit random generator 1. So what you're saying that this random generator task, random number generator, take this task and execute it in a different thread, and whatever result you are getting, you initialize that into this thread, this variable, right? You assign the value into this variable. Correct? Okay, fine. The next line is similar, that int random number 2 and generator 2. Now, when main thread is going to execute through these lines of code, let's say main thread came here. When the main thread is here, it asks that, okay, execute that thread and do all that and get the value. But until or unless this thread completely executes and gets the random number and initializes this variable or assigns the value in this variable, will the main method be able to move forward? Until or unless the complete execution happens here, random number is generated and then assigned in this variable, until both the tasks are completed, will the main thread be able to move forward? Tell me, yes or no? Similar to this, right? Until or unless you don't calculate this function's value and assign this variable, will the main thread be able to move forward? No. There are two tasks here. Complete this execution and assign the value. So everyone, if the main thread is waiting that, okay, once this thread executes, gives me the value, then I will go and call the second thread. Tell me, is it multi-threading anymore? Is it parallelly working anymore? Is there any advantage of doing multi-threading here? Because you are doing things consecutively, right? You are doing things in a consecutive manner, right? You're doing things in a consecutive manner, because what you're doing is you're saying that, okay, first execute this task in a thread. Once this thread executes the value, give me this, assign this value, then only I will go and submit the other task. So I am completing one task, then I am completing the second task. That means you are telling your friend that, hey, wait for the money to come and then only you go and arrange for the bed, arrange for an ambulance and do all the tasks. No, that is not how it should work. What you should say, take this debit card and go and do your things that you have to do. By the time you reach to the hospital, I will arrange the money. That is working parallelly. That is what is working parallelly. Similarly here, instead of giving the actual value, actual integer, you don't give the actual integer, you actually give a promise, you give a placeholder. So instead of giving the actual integer, you give a promise. So what this thread says to main, hey, listen, I don't have the value, I don't have the random number with me right now. You don't have to wait. Take this placeholder, take this promise from me. I will definitely give you the value. For now, move forward. For now, move ahead. For now, just do and execute your next job. I will, in the meanwhile, keep parallelly processing and generate the number and give it to you. Okay? I'll generate the number and give it to you. So this is what is happening here. Okay? This is what is happening here. That the thread says that, take this placeholder. I don't have the number with me right now. Take this placeholder, assign the value and move forward. So this is what is happening in the same scenario. You are telling your friend, take this debit card and go and do your other work. By the time you need it, I'll arrange the money. Okay? This is clear? Is everybody clear with the concept of future? What is future? Everybody clear with the concept of future? That's a different story, Raj. If execution occurs, then you have to handle it, but that's a different story. Okay. Now let's come to the second part. With just the debit card, will your friend be able to do anything? Just the debit card without the money, will your friend be able to do anything? No. Similarly, just with future, will I be able to do anything? Future is just a placeholder. Future is not the value. So to get the value, we have a function called get function. We have a get function. Let me know if you guys can see the screen. Visible, everyone? So similarly, I'll create another future for this. This will become random2. Oh, what happened? I think I did a mistake. Let's come back here. Random2 R2. Now, if you want the number, what you do is that you get int random integer equals to random1 dot get, and then you do random integer 1, random integer 2. It will give me an exception. It might give me an exception. Random number 2, and then I'll print out the sum. The sum will be printed out plus random integer 1 plus random integer 2, and I'll also print the thread name, thread plus thread dot current thread dot get name. So this is what is happening. Now, everyone, let's run this code and see if it is working fine or not. Let's see, first of all. Yep, it is working fine. We have the sum. So you see random number generated with thread 1, random number generated with thread 2, and the sum is done by the main thread. Clear? Clear? Now, the question is, what is this get function doing? What is this get function doing? So the get function is getting the value from the placeholder future that you have given. Now let's imagine something. Let's say that you get the debit card. There's one scenario that you gave the debit card to your friend, and by the time the debit card the friend reached to the reception, the money is already present in the card. Okay, the money is already in the card. Will there be any problem in that case? Will there be any problem in that case? No, it is already in the card. Similarly, let's say we got a future. We reached to the part of the code where we need the value, so we did a get call, and the value is already present. Will there be a problem? No problem. No problem. But imagine that you gave the debit card, your friend reached to the reception, and the money is not there. What will happen in that case? Your friend will get blocked. It will not be able to move forward. It will not be able to do anything else. It will get blocked. It will not be able to take things further, give you a call and ask you. Basically, it has to wait. It will have to stay there, wait for the money to come in. Similarly, if for some reason, for whatsoever reason, if you don't have the value yet, the get will block the process. It will not move forward until or unless you don't have the value with you. It will keep on waiting. It will not move forward. It will keep on waiting. Clear? So always remember, the future.get, the get call in future is a blocking call. So a lot of people ask one question in interviews, which people get confused, is that, is this a blocking call? Everyone, is this line a blocking call? No, because you're giving the future. The main thread will keep on executing. It will not get blocked. But is the get function a blocking call? Yes, it is. And let me show you how it is a blocking call. Let me also prove that to you. Why will you trust my words? I'll have to prove it. Are you able to see my screen? Just a second. What is happening? Something is wrong. Screen visible? Yeah, okay. So, okay, cool. So now what I'll do, see, right now if I run the code, let's print out a simple line here, okay? Hello world, and I'll print the thread name as well. Thread dot current thread dot get name. So what I'll do after this get calls, right? After this get calls, I'll run the code. Do you see everything is working smoothly? See, hello world thread main, Everything is working smoothly, no problem. Sum and everything is coming up. Now, what I'll do, I'll go to this random generator, and what I'll do, I'll say that, okay, you do one thing, you take 5 seconds of time to generate the number. So every time I call the random number generator, it will take 5 seconds of time. The thread will wait for 5 seconds and then it will generate the random number. So in that case, will this get call work, everyone? Let's take this line here also. Will it work directly? No, it will wait. It will get blocked. So let's see what happens. Okay, we are generating two numbers with 5 seconds. So will it wait for 10 seconds or will it wait for 5 seconds? What do you think will happen? There are two random number generator, right? We're generating two random numbers. Each is waiting for 5 seconds. So what will it be? Will it be 5 seconds or 10 seconds? Forget about CPU issues and all that. Let's imagine everything is working fine. Just tell me what time will this take? 5 seconds or 10 seconds? 5 seconds, right? Exactly. Because why? Because they are running parallelly. They are two different threads. That also proves that they are running parallelly. So let's see. Let's run the code. Let's run the code. Hello world thread main is printed. This one. Random number is not yet generated. It is waiting. Then you got the random number generated. So do you see the wait? You see the wait? See this. See, it's waiting. Done. That is why the get is a blocking call. This is before get, right? And this is after get. So you see the get is the blocking call. Right? Let's rerun this. Wait. Now it comes. Clear? Cool. That it is waiting. The get is a blocking call. So that's it. That's it, folks. I hope this is good. How many of you enjoyed the session? How many of you understood future, get, blocking, non-blocking, callable? Thread safe and all is a concept related to synchronization. We will discuss that if you join Scalar in detail. But I hope that was clear, all of you. Awesome. Cool. I will share the code. Just stay back. I'll share the code with you right away. Don't worry about that. You'll get the notes as well. The team will share the notes with you. But my point is, everyone, that did you understand? And now being honest, now let's talk about the scenario, right? What happens in the industry? You do DSA crunching. You do a lot of things. Somehow you make it to the company. But if you don't understand these things, would you be able to write the code in this way? Will you be able to debug the code if you write in this way? No. So that's why it's very important to be an all-round developer. That's what I was saying. You need to know DSA, you need to know design, you need to know these fundamentals like multi-threading, you need to know high-level design, you need to have very good development and project building skills. So reiterating it again, if any one of you, yes, Abhinav, I am a regular tutor in Scalar. I take low-level design, project module, development module, and I sometimes also take high-level design. So I don't teach DSA. I used to, but now I am into development and design sessions. I take LLD, HLD and all that. So if you guys are planning, I would be happy to see some of you in my batches. But before that, if you are interested to know more about Scalar, if you want to understand how things work, if you want to understand what the course is like, if you want to understand the curriculum and everything, I'll request Sunjati to please launch the callback poll again. The wow factor I see from all of you, you were saying this is great, this is great, this is great. Trust me, we create this wow factor every day in the class, right? We create this every day in the class. Okay, so it's not something that is for today. It's every day in the class. And the reason that I told you in the very beginning, right? Today we started the lecture with approximately 450 people. We are more than 350 people still remaining. That means all 350 of you were interested in learning this. It is not like your college curriculum, your college professor teaching you basic things. Even if you want to learn, you are not able to learn, right? So it's more important to have a good learning outcome and to have a good people around you to teach you that. That's when the spark happens, right? And that's what we try to do. So that's what is for the day, right? I will request Sonajyoti to take it further. So Sonajyoti, you can go ahead and take the polls, and in the meanwhile, I'll take the doubts. Sounds good? Yeah, you have to stay back because I've not given the codes yet. I'll give the code link. You have to stay back for that.
Absolutely. So this is something very important for Sandeep as well. This is what ensures, and this is how we evaluate entirely in terms of our master classes, like how well Sandeep taught you throughout this master class. How did you enjoy this entire master class? So if you can just give 10 out of 10, if you felt okay, Sandeep had done something amazing when it comes to making you understand the topics when it comes to multi-threading and Java concurrency. You can just share your responses in this. Guys, we want some active participation in this poll because it's majorly very important for us to understand how did it went for you when it comes to these sessions here. Coming to the second poll, how do you rate the pace of teaching in this masterclass? So if you love the way when it comes to Sandeep, how did he portray this, the nitty-gritties when it comes to multi-threading and like Java concurrency and all those things in a very smoother format. If you felt that, you can just give a 5 out of 5. If you felt okay, you want to just linger around when it comes to the numbers as well, you can just do that. It's completely upon you. But make sure you are participating in these polls actively, because this is very important for Sandeep and us as well, so that we can also make the certain changes when it comes to the upcoming master classes.
Somebody asked a question that the first thread will take 5 seconds and the second thread will take 5 seconds, and overall it's 10 seconds. It's not actually. The first and second, both the threads will run parallelly. Each one will take 5 seconds, but parallel. Like first and thread are running parallelly 5 seconds. So the overall time spent is actually 5 seconds.
Cool. The third poll is on your screen, guys, right now. So if you felt this masterclass engaging, so like if you felt like Sandeep was amazing throughout this entire session, you can just again give a 5 out of 5 here. Like, whatever it is, guys, kindly do participate in this polls. It's around like 303 people. So we want somewhere around like good number of people responding in these polls. Come on, guys, we want more than 50% active participations here, at least, so that we can understand.
Rajat, but first get is blocking. No, Rajat, that I get your point, but you have submitted the tasks. You submitted the tasks, correct? So because you submitted the task, that execution started there itself. So the 5 seconds ka delay started when you submitted the task. It's not like you did a get and then it starts executing. You have, so if you see, right, if I just show you the code, just let me know if you guys can see the screen. I'm not sure which one I'm sharing. I should be sharing this one.
While Sandeep is sharing his screen, let me just share the last poll walk with all of you, because you were...
Yes, please complete the polls, folks. This is very important.
You people were shouting so much love for him. Like you were saying, he was amazing and all those things. So please kindly shower those love in terms of this polls. This is more essential for him in terms of this poll. So definitely don't forget to do that once again.
Yep. So if you see here, the time starts from here itself, the submit, because submit is not a non-blocking, is not a blocking call. So both the threads get submitted. When you come to this get, yes, it is a blocking call. It will not move to the next line until you get this. But because this get completes at 5 seconds, both of them execute almost parallelly. It goes sequentially, but it looks to us as parallel. Submit is not blocking. Get is blocking. That is why both the tasks get submitted. I hope that was clear.
Cool. Awesome, guys. With this being said, we were left out with one important poll. Like for the people who missed out on the opportunity to connect with Manideep and especially Bhaskar as well, I will just quickly share the poll for the last time. So again, guys, reiterating the fact, this is a completely free of cost service that we are providing from Scalar. Okay, so the best part is that you will be connecting Manideep in a one-on-one format. There is no Scalar that is getting involved here. So whatever questions you have based on, if you want to see yourself in terms of similar positions, if you want to understand their journey from where they are coming from, like how, like in terms of the salary figures, where they are standing right now, anything, whatever personal questions you have, this might not be the right platform to address. Feel free to click on yes, and definitely the team will get back to you when it comes to connecting.
Madan, how will you do the get before submitting the task? I mean, you're saying that I will withdraw money before getting the debit card. How will that work? I need the debit card first, then I can withdraw the money, right? So I need to submit the task first, then I do the get. So that's not what you're saying is not possible. Rajat, I saw your question multiple times. The reason why I'm not answering that because your question is very vast. You're saying how trading platforms use multi-threading. I mean, that's like saying that. That's like saying how the ocean water is coming to my glass that I'm drinking right now. It's saying like that. So, I mean, there's a very long process involved in it, right? The ocean water gets condensed and becomes rain, falls, goes to the groundwater, gets boring, and similar to what you're saying, right? So, how the ocean water reaches to your glass, similarly, trading platforms use the multi-threading. It's a very big thing. It's not possible to answer this, right? Go step by step. Don't say don't. I mean, it's okay. Curiosity is good, but build the curiosity step by step. That will help you to understand more, right? Okay, Rahul is saying I heard Scalar many times from Scale friends, but today's session I understand why they told to go for Scalar. Nice, thanks Rahul. I'm really happy to see the positive comments. I hope you guys enjoyed the session. Now I will hand it over to Swarna Jyoti. Had a great time with all of you. Thanks for being so active and thanks for putting your time for learning. Bye bye. Have a great time ahead and see you all in my future matches. Shalom.
Thank you so much, Sandeep. Again, thank you so much for this insightful session. We loved the way you portrayed all the things in such a prolific manner, in such an easy manner as well, because many of the people were, when the session started, people were inquiring like, where did we for freshers? How would we be looking forward? So amazing job done on that part. With this being said, guys, I can still see a lot of questions that are being piled up. So for the people, I'm just launching the callback poll for the last time here, guys. Just give me a second. So if you missed out on the poll by any chance, many of you were asking about the fee structure. They want to connect with the career counselors. They want to understand the like how to get like the admission part when it comes to this particular program itself, right? How to like actually avail the scholarship. The best part is that you can connect with the career counselors. You can just jot on all your questions, whatever is the concern. It could be a very silly question. It could be something if you're looking for a transition, if you're stuck in terms of your career, whatever it is. You could just indulge in this poll and the team will be getting back to you within 48 hours or so. With just make sure you are just prepared with all your questions, because this is something like a one-time opportunity for all of you. Again, coming with a free of cost service. Cool. Thank you so much, guys, again for interacting in the poll. With this being said, I will just quickly share all the links, relevant links once again, so that you are not missing out on anything before we drop off from the session here. So again, the people who missed out on the link here, I will just quickly. So again, reiterating, we have got a free class coming from Anshuman Singh. For those of you who don't know about Anshuman, he's currently the co-founder of Scalar, and he's also one of the founding members when it comes to Facebook Messenger app as well. I will quickly share the link with all of you. Feel free to register for this particular event if you want to understand how to crack like high salaries, how to present yourself when it comes to the interviews. For that, make sure you are registering yourself for this particular event, because it will be a very short and dynamic session wherein we specifically like make our understanding on very small segment of people. That's the main ideal focus for this particular class itself. Okay, let me just share the other relevant things as well. So guys, if you love today's masterclass, if you want to share your feedback, if you are willing to see any sort of other topics as well, feel free to give your valuable response when it comes to this feedback form itself, so that we are on the same page. We can understand how this thing works for you as well. If you loved like anything about Sandeep, if you want to see anything, change the content, curriculum, anything, if you like, you can just post it here. Shubha Singh, don't worry, I will share how to get the certificate and everything. Yes, Shishir, for the enrolled learners, you will be getting the recording here, so don't worry on that part. And last but not the least, for the people who want to take part, so similarly like this, we have got another platform called as Scalar Topics. You can just click on this link and explore that particular platform as well. So wherein different instructors will be helping you with a lot of different topics as well, wherein you can get some free certifications. You can understand topics in a very short duration and get a good outcome as well. So definitely you can check out this particular link as well to understand like for example, if you want to learn Python in a short manner or so, there will be instructors who will be teaching there. So definitely you can this is something you can again look out for. Cool. With this being said, I will again post the link for the WhatsApp group so that people are not missing out on the notes by any chance. And for people who want to connect with Manideep and Bhaskar as well, I will just quickly share the link for the last time so that if you have clicked on yes in this particular poll, if you want to connect with them on a one-on-one format, just make sure you are joining in this particular WhatsApp group wherein they are waiting for you to get your queries getting answered. Shubham, I will let me just share the events link with you so that you can just check whatever the relevant free free master classes that is coming up in the upcoming times. You can just surely check it out here. And for the people who were inquiring about the certificates, let me just tell you how this thing works again. So this is the link for the particular same event that you have registered. Okay. So by tomorrow at around like 11 a.m., just tune in again on this particular same link. Okay. Just to download the certificate. It will be there in the top of it only. So you won't be finding any sort of difficulty to download the certificate as well. With this being said, I think we are pretty much done with the session. Let me just check once. Give me a minute or so. Cool. With this being said, guys, thank you so much for joining in today's masterclass with Sandeep Sinha. Look forward to see you in upcoming masterclasses as well, and Scalar if you are planning to join Scalar. Look again. Feel free to post in all your feedbacks and comments in the meanwhile. With this being said, have a great weekend ahead. Stay safe. Good night to everyone. Bye-bye.